Hello everyone, I want to welcome you to our second day of our conference, and at the beginning I would like to make some just small recap of the first day of this conference. At first I want to say thank you to all our sponsors which are on the screen. And first day we had about 15 sessions, 5 lightning talks, 3 workshops, and 1 panel discussions about platform engineering. At the first day we had 23 speakers, and we have here 7 booths with the sponsors and 5 workshops. You can find the pictures from the day 1 on the QR code. So please, if you want the pictures, to see the pictures, scan it, and we will also send it by email. There are the pictures from the day 1. Okay. Today there are also some fun activities from the sponsors. You can go to the Pure Storage booth for the fun swag. Also, the Prusa Printing 3D is able to print you almost everything you want, what you can find on Prusa Printable or any other site on the internet. And there will be some raffles from the sponsors. Perfect Scale starts at 2 o'clock, so everybody who registered there or who want to register, please go there and register. At 2 o'clock there will be a raffle, and then at 2:30 there will be the quiz at Red Hat. Also possible to win a lot of interesting things. And Dynatrace will have the raffle at 2:45 p.m. Here is our picture which we take at the end of the day 1 and say hello to everybody. Okay, this is our program for today. We start at 9:20 in this room and the smaller room. There you can find a lot of interesting presentations, maybe architecture and future-ready cloud native platform from Jakub Stehlik and many others. And also this is from the afternoon. There you can also find maybe the úvod do monitoringu pomocí Prometheus from Ondrej Šika or something in English. Also we have today some workshops. The workshops start at also at 9:20, and we have today just 1 workshop room, and is the more far of workshop room, and this workshop room here was changed to a silent room. So the workshops will be on the other side where was the catering. Today, at the end of the conference, we will have a raffle, and there are really interesting things like 3D printers, some stuff from the sponsors, and also some swag from CNCF. Okay, thank you for listening me, and enjoy this day. Thank you.
Hello. Good morning and welcome to our first presentation of the day. Day 2 of the Kubernetes Community Days will begin with a presentation of Juan Velasquez and entitled Autoscale to Excel. And it's all yours.
Buenos días. Espero que aquí todos hablen español. ¿Todos hablan español o? Okay. So, if you weren't awake, I hope that catch your attention a bit. I know it's early in the morning. I hope you grabbed your coffee. So, my name is Juan. I work at Pure Storage as a software engineer. We have a booth here outside. If you need some socks or a pen or a job, please stop by. We can talk a bit more about the company. Oh, grab this. So I'm going to present how to scale to Excel. If any of you thought that this was going to help you with your spreadsheets or that I was going to talk about VLOOKUP, please let me tell you that I'm going to be talking about Kubernetes autoscaling and specifically about one of our services, which is Perf Worker. I will start giving you an introduction of the service, telling you what it does, how it does it, why is it important. Then I'll move on to the infrastructure. I will tell you how it was looking at the beginning when the company was in its early stages and how it has grown now that the company has become like a leader in the storage industry. At the end, I will talk a bit about the challenges that we still have today with the service and where we are. So maybe, hopefully, you will guys give some ideas. We can stay in contact at the end. So, Perf Worker. Perf Worker is a service that generates performance report from customer logs. These logs allow us to keep track of devices that we have deployed around the world. Specifically, we use this performance report for customers that need support on their devices. We need to make sure that the devices are performing as expected. When the customer has a problem, the worst thing that we want is the customer to come to us saying, our device is not performing as it should be. What we want is to tell the customers in advance if they have some misconfiguration or if they are using something wrong, so we can fix it and avoid these issues. The way this service works is basically it's ingesting some logs that come from these devices. We process them, we parse them, and then we generate from some metrics the performance report. This is the initial infrastructure or the starting point. So as I said, when the company was still in the early stages, we had just a couple of hundreds of clients. We had some S3 buckets where the logs were coming in. We would just fire a notification with SNS. This notification would be stored in a queue in SQS. And then we had Perf Worker, which was running on EC2 instances, just pulling messages from that SQS to consume the logs and then generate the reports. These are like some of the issues or the most important issues that we had with this approach. The main one is operational overhead. There had to be someone there doing the scaling. You know, if we deploy a new device, then there had to be someone there scaling up the EC2 instances or scaling down if we were over provisioning. Because of this, there was a delayed response to the demand of EC2 instances. So if we deployed a new device, it would be it would increase the load, but it would come after some monitoring or some alert would trigger it, so it's delayed because of this. Also, there was some resource inefficiency. We would be, as I said, over providing in most of the cases, which means that we will also spend a lot of money on the computing, yeah. Also, issues that we found were like, once it stops working, it doesn't, it just stops. Someone needs to go and start spin up a new instance. Well, in the best scenario, it would be just that it runs out of memory and we just need to provide either another instance or, yes, like scale it vertically. But the main problem here was when there was an issue with the code, with the actual code, then it would be a nightmare because we would have to go into the EC2 instance and check the logs, and you have a bunch of processes that they're running different logs, so the observability was a nightmare. Also, when you have to do maintenance from time to time, as much as you want to avoid it, there are some times when you have to do it, the service then will stop working, the queue will grow rapidly, and yeah, we'll have issues there. Also, I mentioned the monitoring. Back then, the monitoring was basically just some alert from AWS, just sending an email. It was a bit, new. Inconsistent performance. We didn't really know how different type of logs would affect each process, as we sometimes have files, some logs that are bigger than others or have different contents than others. And also, this affects the service reliability. This is a service that needs the SLA, it's 99.9%. It has to be performing almost perfectly. So our customers are covered. So then, as you might have guessed, we did some EC2 autoscaling. Don't worry, I'm going to talk about Kubernetes. This is just autoscaling on the EC2. So this solves a couple of things, right? Now we don't spend as much time on the engineers don't spend as much time just going to the instance and scaling it manually. We have we save some time on the delayed response, or also efficiency and costs. We also, somehow, the complexity of the management is easier. This is all taken care of, but we create we find out about 3 new things. Lag indicator. So we're scaling based on resources. So basically, we're scaling once we are running on like 90% of memory or high CPU usage. So we are scaling once we are starving already. So also we have limited metric options. What I mean by this is we can scale only by CPU usage or by memory usage in most cases. And also this brings more, you have to set up some policies for the scaling, which is, not ideal. But at this point, the company, we have a team at the company for developer experience, and they came up with a tool to help everyone deploy their applications in an easier way. This tool uses Gradle, Artifactory to store the artifacts, and Spinnaker to deploy these artifacts on the Kubernetes cluster. So this was a big effort to containerize this application, and the current infrastructure just changed from EC2 instances to pods running on the Kubernetes cluster. So this is how it looks now. So some things that we really liked about this change were like definitely the deployment and went like much faster. We had the CI/CD pipeline set up somehow. It saved us like a lot of trouble there. Then we had already a Docker image, an artifact that would allow us to deploy this application basically anywhere. You could debug some stuff locally and so on. Portability, as I said, we have this Docker, so it's environment agnostic. You can basically deploy it anywhere. Also with Kubernetes, the guys implemented some monitoring and observability, which was basically Datadog and Graylog for the logs. We also set up some monitoring for, we finally could use some real monitoring. We created some metrics on the code to keep track of the performance of the service to make sure it's above 99.9. Also, we started measuring the time it takes for certain processes to generate the report. We could measure how long it takes on the creation of the report. We measure how much time it takes for the logs to be processed. So all this new information has helped us understand better what the application is doing and where the real issues are. Also, developer productivity was increased since we weren't wasting much time in the boring scaling up or scaling down, trying to understand how many instances you need for a new load and so on. And of course, this simplifies the DevOps. But we still had some issues. If you have a Kubernetes cluster, you also need people to understand what they are what they are getting into. So even if the team that is in charge of the Kubernetes cluster knows perfectly Kubernetes, you still need the teams who actually use the Kubernetes cluster to understand how to use it. So this is sort of a drawback in some cases. You need to learn about it. It takes some time. That's cool. But also we had another important factor, which was the lagging indicator or the reactive scaling. Basically, we were still stuck with horizontal pod autoscaler, which basically means, like in most of the cases, you scale based on CPU or memory usage. And also you have someone to set up the Kubernetes cluster at the beginning, set the deployments, and so on. You still have the resource management issue because even though the autoscaling is set up there automatically, you still waste based on this reactive scaling. Waste some resources on this reactive scaling. So, what did we do? Well, at this point, the company decided to invest more on the service. We went through a major refactoring on the service level, on the logic of the service, and what we did was we took this multi-process service and we made it so it would run one process, would just consume one log, and that way we would have like a more granular approach when trying to debug some issue or trying to understand why some log might be taking more time to be processed or might take more time to actually get into the processing. We still like, so what did we do? We started using KEDA. For those of you who don't know, I think everyone does, but it's Kubernetes event-driven autoscaler. KEDA allows you to use different scalers. Basically, you can use most of AWS and Azure services to scale your deployments. You can scale basically on pretty much all the native cloud native stuff out there. So what we did here with KEDA is we started scaling based on our SQS queue size. So this way we would understand how many logs we were supposed to process, and before we start starving, we actually start the scaling up. So since we have one pod or one job running one log, then this would allow us to consume them rapidly and decrease the resource waste as much as it can be reduced. So with this, just as a recap, we went from some easy to manual scale, big chunk of code, processing many logs at the same time, to just specific pods running just one log at a time that allow us to debug and monitor the service much better. So I came here to learn more about what options are out there for us and what we can do better. I have already heard of, a carpenter for AWS on EKS, which would allow, right now we're using autoscaler groups for nodes, which I didn't know it takes a lot of time, and the carpenter will just spin up a new node just as it goes. So if you have any ideas or any suggestions, please, this is my LinkedIn. Please contact me, or if you want to talk about something else or the company, don't hesitate to contact me. And that's it. I'm ready for your questions. If you have any. Perfect. Thank you, guys. Have a great day. I'll just drop it here.
Thank you very much. We had a very rare event that the speaker actually gave us some time. I didn't have to use my clues. Thank you very much for that. That was a nice change. We'll be continuing with the next presentation, but there is still some time. So if you want to get a coffee or something or stretch your legs, now would be an excellent opportunity to do so. Thank you. Hello, everybody. I hope you had a good coffee break. Allow me to welcome our next speaker, Jakub Scholz from Red Hat. He will be talking about very interesting subject of storage in Kubernetes, and namely about stateful sets and what can you do when they are not enough. Thank you. It's all yours.
Thanks, and welcome everyone to my talk. My name is Jakub Scholz. I work as an engineer at Red Hat, and I'm one of the maintainers of the Strimzi project, and occasionally I'm also a contributor to Apache Kafka. If you never heard about Strimzi, then it's a CNCF incubating project, which is of course open source under Apache License 2.0, and it's focused on running Apache Kafka on Kubernetes. Apache Kafka, I hope you all heard about it, at least in some rough ideas. It's a stateful application. It's a data streaming platform or event streaming platform. It stores the data typically on a block storage. What we do in Strimzi is we provide operators to make it as easy as possible to run it on Kubernetes. We actually have several operators. One of them is kind of the main one for running the server components. Then we have some additional ones for managing the users and topics. And we have some more tools as well to kind of make it as easy as possible to use Kafka in the Kubernetes environment. What I will be talking today is kind of our journey where we started by using the stateful set as something what Kubernetes gives us out of the box. And then through different challenges and problems and limitations, we kind of over the years run into the situation where we left the stateful sets behind and we are not using them anymore. How many of you have ever used stateful sets? Okay, that's almost everyone. I will just quickly go through some intro so that everyone knows what we are talking about. Stateful sets are basically a workload API which is part of Kubernetes, which is designed for running stateful applications. And saying it was designed for them is maybe a bit overstatement. It does two basic but very important things for the stateful application. It basically creates the pods with predictable and stable names. So when the stateful set creates the pods which are running the actual containers, then the names are always based on the stateful set name and some index or some ordinal number. And these names don't change even if you delete the pod or if the pod restarts, the name will be always the same after a restart. So that's different from deployment where you have these random parts of the name and they change all the time. And actually in Kafka, this works quite nicely for us because we, for a long time, used to have two stateful sets, one for the Zookeeper cluster, which Kafka used kind of for bootstrapping, one for the Kafka cluster. Both Zookeeper and Kafka, they have their own kind of node IDs, server IDs, which can be easily mapped into the stateful set ordinals, and they are used as the IDs. And so that fits quite nicely. And the second thing which the stateful set does, which is very important for the stateful applications, is that it has this persistent volume claim template, where in the stateful set you can specify the template for generating the PVCs, the persistent volume claims, and when the stateful set creates the pods, it also creates the PVCs accordingly for each pod one PVC. So that allows you to, for example, have a stateful set which creates 5 different pods, and each of these pods has its own persistent volume claim and persistent volume for storing its data. So again, that fits fairly well. If you have never seen a YAML how the stateful set looks like, but from the hands up, I guess most of you have, then there is, as usually, the label selector for selecting the pods belonging to the stateful set. There are the replicas, which specify the number of the pods which will be created. Then there's the template from which the pods with the containers are generated. And then there's the template for generating the PVCs, which are then mapped against the pods and mounted into the pods. And when you create the stateful set, then you will see something like this, where Kubernetes take the stateful set and they create all the different pods, get them running. And you can see here the names. They are always name of the stateful set, -0, -1, -2, and so on. So that's kind of the basic stateful set. What the stateful set also supports are rollouts or rolling updates, which are important if you want to change how the pods are configured. So you can change the stateful set, and Kubernetes will by default kind of automatically roll your cluster, your stateful set, all the pods. And the way the rolling update works is that it basically relies on the pod readiness probe. So it basically goes, deletes the pod, starts the pod with a new configuration, waits for the readiness to be ready, for the pod to be ready. There are different timeouts and so on you can configure, but it's all driven by the readiness probe. And then once it's ready, then it basically moves to the next pod. And another thing which is part of it is that it does this always in a fixed order. So it, I think it used to start from the end, from the beginning, from the lowest numbers. Now I think it starts usually from the highest numbers. But yeah, it's basically fixed. Kubernetes do everything for you, and that's how you roll out any changes to the stateful set. And it looks something like this. So if you change, I don't know, some command in the container, you will see how the pods kind of one by one are deleted, started, get ready, and then the next one is rolled again until yeah, the whole stateful set is basically rolled. Now, in Kafka, we very quickly found out that this is not sufficient for us because we want to have our own order in which the pods are rolled, and we want to be in control of the timing under which the pods are rolled. This is, for example, because in Kafka, but also in Zookeeper, one of the nodes, one of the pods is always kind of a leader, and the other are followers. The leader has a bit special role. You want to roll it as the last one so that it doesn't kind of change during the rolling update every time the pod is deleted. And that's actually something what's quite common for many stateful applications. What's maybe not that common is that the way Kafka works, the readiness, if you see the readiness probe as when the clients can connect, then that's one thing, but then you have also the synchronization of the distributed data across the pods, where to maintain the availability, you want to wait for the data being in sync before you kind of move to the next pod. So that's what we wanted to do with our Kafka. And actually, this is quite easy with stateful set because the authors thought about these things, and there is this update strategy configuration in the stateful set, you can change it to on delete. And that means that when you change the stateful set, Kubernetes won't actually do anything by default. And it will basically wait for you to delete the pod, and only when you delete the pod, it will recreate the pod with a new configuration. And that way you basically control the rolling update because yeah, you can check all the pods. You see, okay, this pod with this ordinal, that's what I want to roll first. So you delete it, and Kubernetes created a new configuration. You wait for the readiness, it gets ready. But you can do additional checks to see whether everything is in sync or not. And only then you decide, okay, the next pod I want to roll is this one, somewhere completely else in the sequence. And this way you can control everything about the rolling updates. And it's great because that's basically part of the Kubernetes stateful sets design. And yeah, you can easily customize this. But then there are some other issues which you run into later if you are working on something like Strimzy. And they actually relate to the persistent volume claims. So as I said, the persistent volume claims is generated from the template which is part of the stateful set. But it means that by default, every persistent volume claim generated by it is exactly the same. They differ only in the name, which again contains the ordinal of the pod to which they belong and so on. And there are some situations when this doesn't work for us. So for example, what was common request we got from our users is the ability to use different storage class for different pods, for the different PVCs. And the motivation behind it was that if you use different storage classes, you can use affinity configuration inside the storage classes, and you can do quite a nice trick around the scheduling the pods. You can quite easily lock the different pods to different availability zones and make sure that the pods kind of stick there, even if you have some rolling updates, that they don't mix between the zones and so on, which is quite useful in some situations. And here we start kind of getting into the gray zone. So what you can actually do is if you create the PVCs upfront from your tooling before you create a stateful set and just use the different storage class configuration, then, well, the stateful set, when you create it, it will see, oh, hey, the persistent volume claims are there, they have the right names, they look pretty much as I would expect it, let's use them. And it simply reuse these persistent volume claims for the pods, and everything seems fine. You have now different PVCs with different storage classes mounted into the different pods, and yeah, that's what we wanted. But this is now not exactly something what was designed for, and for example, when you need to do some storage operations like one of the volumes is broken, you want to delete it and recreate it again, then you can easily get into race conditions with a stateful set, because if you delete the pod and the PVC you originally created and try to create a new PVC again with your special storage class configuration, then suddenly the stateful set jumps in and creates its own PVC quite often before your operator can create the one you want. So you often have to kind of, for example, delete the stateful set without cascading, recreate the things, and then recreate the stateful set to get the pod recreated. So you can have some problems, you might need to deal with them. It's already a bit hacky. What's even worse is that in Kafka, it's quite common that you want to add or remove volumes to the pods. This is because Kafka was basically designed from the beginning with the idea that it wants to use just regular disks. It doesn't need to have any complicated RAID storage where you kind of create some huge virtual disks out of many physical disks. So it's quite common that you simply use multiple disks just to be able to store many and many terabytes of data in each Kafka broker. So you need to use multiple disks to increase the capacity. But sometimes it's also about performance, because with more disks you get more throughput of the storage I/O. So it's quite a common issue, but unfortunately, if you would try to edit the stateful set and add additional volume into the template for the PVCs, then what you will find out is that it's read-only. Kubernetes don't allow you to change it. So we tried, and yeah, of course you can hack around it to some extent. So what you can do is you can do non-cascading delete of the stateful set. Non-cascading means that the pods will remain there as they were, still running, but the stateful set will be gone. And then you create again a new stateful set where you add or remove the volume from the template. And again, in our case, we would pre-create the PVCs first, but that's not that relevant here. But what would happen is that then you would have the new stateful set with the change disk configuration, and you would have the old pods. So now you would need to roll them to have the new configuration. You can do that again, but actually this time you cannot do the custom order in which you roll them. You have to roll them from zero, otherwise Kubernetes, the stateful set controller, will just start spitting out some errors if you try to do that from the middle somewhere, because it will simply not be able to reconcile the different volumes configuration in the pods and in the stateful set. So again, we were able to work around it. It was very important for us, but we are getting even more into this kind of, it's more of a hack than how it was supposed to be used. So we solved that one, even through maybe a bit hacky way. And the next thing we were running into were the custom ordinals. So originally, when Streamsys started 5 or 6 years ago, the way the stateful sets always worked is that the index numbers, the ordinals started at 0, and then they continued up in a sequence. So if you had 3 replicas, it was 0, 1, 2. If you had 5, it was 0, 1, 2, 3, 4. In, I think, Kubernetes 1.27, this changed a bit. So you can now configure the starting index number. So you can, for example, say, I want the index numbers to start at 10, and with 3 replicas, you get 10, 11, 12, and so on. You get the idea. And this ties also to the scaling up or scaling down of the stateful set. So by default, what happens when you scale up or scale down the stateful set is with scale up, it always creates a pod with the kind of next highest ordinal number. So if you have the 10, 11, 12 and scale up, it adds pod with the ordinal 13. And if you scale down, then it actually goes again from the back. So it will remove the highest pod with the highest ordinal. You can actually hack around a bit with this, this option to change the starting ordinal. So if you go edit the stateful set and you, for example, increase the replicas number, but also change the starting number from 10 to 9, then what would actually happen is that the new pod which will be created will be on the beginning. So it will be the 9. And similarly, if you want to scale down from the beginning, you can kind of edit it, scale down the number of replicas, and at the same time, change the start ordinal, and again, it will remove the pod from the beginning. But you never can really remove the pods from the middle. So if you have the pod 0, 1, 2, you can't say, let's remove the pod with the ordinal 1. And sometimes this is quite important in Kafka because you have terabytes of data on each broker, and sometimes, I don't know, you are decommissioning some project which didn't succeed, and most of these data are on the broker somewhere in the middle. So you want to save all the effort and time and just delete the broker from the middle. It would be easy, but it's not really with stateful set. But to be honest, when the users started asking for this, we were like, no, that's not worth it. In Kafka, you can actually use something called rebalancing, where you kind of reshuffle the data between the brokers. And you can kind of say, okay, the data I want to delete, they are in the broker in the middle, but let's move them to the broker at the end, and the data from the end to the middle, and then delete the broker at the end. And it will cost time. Sometimes it will cost money because of the data transfers and so on. But yeah, this was something where we said no, and we basically didn't implement this for a long time. But then what happened to us was this idea, let's remove Zookeeper from Kafka. It's something called craft. It basically means that the functionality which Kafka was using from Zookeeper is being implemented in Kafka itself. And the Kafka, it won't be anymore that we have the Zookeeper nodes with the Zookeeper cluster and the Kafka nodes with the Kafka brokers. We now will have only the Kafka cluster, or we actually, it's already implemented, so we already have it. And some of these nodes, they will be these controllers, some of these will be the brokers, some of these might have both roles at the same time. But what it means for us that it creates this asymmetric configuration problem, because the controller needs to have one configuration, the broker needs to have another configuration in terms of some Kafka configuration file. But also, the controller itself typically doesn't need that much resources, it doesn't need that much storage, whereas the broker that typically has quite a lot of memory, quite a lot of CPU, and huge amounts of storage. And this is a problem, because with stateful set, all the pods are created in exactly the same way, so they will look the same. And when it comes to the configuration of your application, you can kind of play around it, right? You can have a config map which has 10 different configuration files. You mount this config map into each pod, but then inside the pod you kind of decide, okay, my pod name has the number 5 in the ordinal, so I will use as a configuration this file with the index number 5. But you can't really do this with the things such as the storage or the resources, because you can't say, this pod number 5 should have just 1 CPU and 2 gigs of memory, whereas this pod number 6 should have 12 CPU and 64 gigs of memory. So this was kind of the thing which kind of broke us, and we started thinking a lot more, is it really worth using the stateful set or maybe not? What should we do about it? And we considered some alternatives. One of the things which we thought about was using a stateful set per pod, which would create these kind of weird pods, for example, my application 0-0, because we would have kind of some index in the stateful set name, then the index will be added from the pod name created by the stateful set, so that might work in a way, but it would look a bit weird. We considered some other tools which already kind of try to aim to replace the stateful sets. There's this project called OpenCruise, which has these advanced stateful set or clone set resources which kind of try to solve some of these issues. And what we also considered was that maybe we can manage the pods directly ourselves. At the end, if you follow the explanation, the stateful set doesn't do that much for us, right? We create our own PVCs. We don't really rely on the templating from the stateful set. We do the rolling update ourselves by deleting the pods. For various workarounds, we need to delete the stateful sets all the time to kind of work around something being read-only. So it seemed like the only thing we were missing was actually creating the pods. And so that's why we were really thinking about it, and does the stateful set really give us something, or are we anyway doing everything on our own? And yeah, that's the question, right? Is it just this what stateful set gives us? And I'm gonna now switch to a demo. So what you can see here is that I have already running cluster. I have here the Strimzi operator installed. Here I have the Zookeeper nodes. I'm still using the Zookeeper-based cluster. Here I have the Kafka node. This is kind of the user and topic operator for managing the users and topics. And if I go here, then if I do kubectl get stateful sets, you can see that there are no stateful sets anymore. So I'm not using the stateful sets. And let's see what happens when I delete one of the pods with the Kafka broker. Not here, I have to paste it below. So kubectl delete pod my cluster Kafka 1. I delete it, and what you can see here, it terminates, but it is immediately recreated. It gets running, and now we just have to wait like 15 seconds for it to get ready. And everything will be fine, right? Because the Strimzi operator saw that the pod was deleted, and it basically just went and recreated it, and that's how it does the job. But now let's try to see what happens if I do kubectl delete deployment Strimzi cluster operator, and that deleted the vol operator which was running there. And now I can go again, and I can delete the pod. And now you can see that it terminated, but nobody is starting it up again anymore, right? And this is just the deletion of the deployment was really just an example, right? You would probably not delete it, but imagine someone decided to optimize some RBAC rights on your cluster and deleted some cluster roles they thought were not needed, but were used by the operator, and it doesn't have the access rights. Or imagine that you are running in AWS, one of the availability zones crashed, now the operator was running in this zone, and it cannot be started because you don't have free capacity right now, and it's not running for that reason. So basically, if you start managing the pods yourself, it means that you are the one responsible for creating them. And in my opinion, that's a huge responsibility which you need to be really careful about. And for example, in Strimzi, until we were managing the pods ourselves, we didn't really need some high availability in the operator, right? The operator was running, it was managing the Kafka, but when it came to some evictions during draining of the nodes or during some availability zones, disasters and so on, it was Kubernetes who managed to recreate the pods. And that meant that if the operator wasn't running for several minutes, it was actually not that a big deal. But now, responsible for the pod creations, it's much bigger deal suddenly. And you have to kind of take into account the difference between the Kubernetes used by thousands, 10,000s, hundreds of thousands of people every day. They all use stateful sets on all different Kubernetes distributions. They all test it, make sure that it works, right? And Strimzi, I think Strimzi is pretty popular. We have thousands of users as well, but like we don't really have the same capacity. We don't really have the same scale of the users to test these things. So you can much easily run into various issues. For example, at one point, the Kubernetes client we were using had some compatibility issue with some Kubernetes distributions where, for whatever reason, some Kubernetes environments badly terminated the WebSocket. the Kubernetes client didn't handle it, didn't reopen it, and it caused that the informers we used to find out that the pod was deleted were actually not aware that it was deleted, and they saw it as running and they didn't do anything. A big problem, right? And if it was stateful set, probably someone would have solved it before. With Strimzy, you then get very small percentage of users reporting this from their environments. You have to somehow get the logging, try to kind of figure out what the issue is, eliminate what the environments are where these problems happens, and you need to solve this. So that's kind of part of the responsibility, what you get out of it. So just to give you some more insights on how exactly we got rid of the stateful sets in Strimzy is we actually kept the way quite similar to how it was when we were using the stateful sets. But instead of stateful sets, we created our own internal resource called Strimzy pod set. And the way this resource looks like is that it's basically a custom resource which contains a list of the pod definitions as they are. There are no templates, no persistent volume claims, it's just pod definitions. And then we have a separate kind of thread class object in our operator, which is responsible for creating these pods. And that's really helpful for us because that allows us to kind of separate the concerns. It makes it easier to test these things because you can kind of test it separately from running some big Kafka cluster. And it allows us to kind of work in the same way, and it helps us to kind of improve this reliability, because if we would do it in the main reconciliation loop of the operator, and imagine you have the reconciliation loop running, it's connecting to one of the Kafka nodes to kind of do some management operation, then there's a worker node crash and this pod disappears. The TCP connection remains hanging for, what, 30 seconds, minute, then it timeout. So like having these separated concerns that allow us to be kind of able to quickly react to the pod deletions. So I think that worked great for us, but it's not necessarily something what has to be copied. I think that's to a large extent defined by how our operator is designed and how the code works internally. And maybe for other tools and other operators, it can be simply done from the main reconciliation loop. Right, so just to give you an idea, this is how the YAML looks like for the Strimzy pod set. So what you can see here is there is the selector as normal in stateful set, but then you have this, this pods list, which really contains just the list with the pod definitions. You can see there just the comments so that it fits onto the screen, but it really contains the full pod definition with everything. There were some other disadvantages and issues we ran into while getting rid of stateful set. So some things work a bit differently if you have pods managed by a standard Kubernetes controller and then you do it yourself. For example, for whatever reason in the pod disruption budget, you can't use this max unavailable option when you manage the pods yourself, but you have to use the min available option. We had also some smaller issues with various tooling. I think some cluster auto-scaling tools had problems when the pods were not managed by some stateful set or deployment when they were trying to evict them. And I think some specific Argo CD configurations had some checks for stateful sets, and when the pod was not managed by the stateful set, it suddenly decided to delete the persistent volume claim despite it looked exactly the same as with the stateful set. And yeah, as I said, you have to keep in mind that you also rely on the Kubernetes clients, you rely on all the different Kubernetes distributions running out there, you rely on the different configurations of the Kubernetes API server and so on. As a conclusion, so just to be clear, although I talked about some problems with getting rid of stateful set, I don't think we have any regrets for getting rid of it. I think we are quite happy with it, and I'm not aware of any problems being reported or anyone having some significant issues with it. That said, stateful set is a great starting point. So maybe if you know already upfront that you will be running into these same limitations as we were and you really will need to solve them, then maybe you should just skip them. But otherwise, they might be the best starting point for you. And yeah, also I covered various different limitations which they have, and I'm quite sure other applications might run into other limitations. Then still, I think it's a huge responsibility you would take over from for managing the pods. So you should be really careful about it, and you should really consider whether that's worth it or not. And yeah, that's it for this talk. And we should have some time for questions. And I can see some on the screen here. So the first one is this strategy now part of the best practices blueprint Strumsy now advertise, or oh, you just deleted it before I managed to read it? But so I think if I remember correctly the question and got the idea, then okay, it's back. No, yeah. Or is it just a way to grant full control over your Kafka cluster? So the way Strumsy works in the current versions is we don't support stateful set and we don't use stateful set at all. So whenever you use the recent version of Strumsy, you are using this mechanism and you are using these Strumsy pod sets. The idea is that you should not really care about it, and there is still kind of upgrade logic. So if you are upgrading from some older version, there's kind of a logic how to smoothly migrate the pods managed by the stateful set under the Strumsy pod set. But otherwise, basically, when you use Strumsy today, then Strumsy manages the pods directly, and it's used out of the box, and there's no other option with Strumsy in the current versions. So I hope that answers that. The next question is, in Kafka with Craft, there will be no special nodes for brokers. Craft controllers will share the nodes with them. So there are different architectures which are possible. If you are more interested into the topic, then I had a talk about this at KubeCon in Paris on Data on Kubernetes Day, or I will actually do a similar talk next week in DevConf in Brno if you are planning to get there. But basically, you can have a dedicated controller node and dedicated broker node. So that would look pretty much like with Zookeeper, where you have some nodes which are responsible just for the quorum and metadata management, and some other nodes which are responsible only for the brokers. You can also use mixed nodes where you have the nodes doing both things at the same time in a single kind of JVM in a single process. These kind of are best suited for different architectures, different patterns, different environments, but you can use all of them. But in any case, kind of the sequence numbers of the nodes, the node IDs, are still from the same sequence. So you will, for example, have controller ID 0, controller ID 1, controller ID 2, broker 3, broker 4, broker 5, and you cannot have controller ID 1 and broker 1 as well, because that would create the conflict. So I hope that helped to answer this one. Then the next one is for the high availability, didn't we have problem with the operator down already with the stateful set because of the custom persistent volume claim pre-creation? Maybe in some cases it was a problem, but in general, if you were facing some worker node evictions or availability zone crashes, then in general the PVCs stay there, and they were still used by the pod for the good or for the bad. So I don't think there were any major issues with this. Then the next question is, what are some of the pain points you have encountered once adopted Craft and moved away from Zookeepers? That's probably for a long discussion we should have had yesterday over the beer. I think there's still a lot of missing features, and the quality of Craft is, to be honest, a bit lacking. Yeah, there are still a lot of challenges, but definitely this kind of dealing with the different architectures, being able to change the roles for the brokers, that's definitely one of the big pain points for me as the operator developer. But hopefully once it will be all finished, it will be all great and smooth for all of us, because to be honest, I don't know many people in the Kafka world who are big Zookeeper fans. So. And the last question is, have have you considered extending Kubernetes core stateful set API as an alternative to creating own pod set? Yeah, we considered it, but it's, to be honest, quite hard because if you would want to do some changes, you would need to do a lot of discussions, a lot of proposals. Everything takes a long time. Then it's probably introduced maybe as some disabled feature gate, and you have to wait for it to be enabled everywhere. And the rollout would be huge and really long. And the Kafka community with the Kraftwerk and so on, that doesn't wait for us or for Kubernetes to be better prepared for this. So yeah, it's it would be nice to over time get some of these things into the stateful set API as it's evolving, as I mentioned, for example, these start ordinals. But yeah, I don't think that would be done in time. And also at the KubeCon in Paris, actually, there were several other people around different stateful applications, around ClickHouse and databases, who pretty much share the same issues, and pretty much all of them solved it by working around the stateful set and not using them, or by some of them not using them at all from the beginning. And I think that's it for the questions. So thanks for being here, and hopefully the talk was useful, and enjoy the rest of the conference.
Really interesting presentation, and now we have a coffee break, and we'll continue at 10:55 with the next presentation. Hello, welcome back. I hope you had a good coffee break and are properly caffeinated for our next speaker. His name is Matej Gera, and he will be talking about a very interesting subject of infrastructure monitoring, comparing Prometheus and an open telemetry.
So, thank you. Hello, everyone. As it was said, my name is Matej Gera. I'm originally from Slovakia, but I live and work in Berlin. So this is one of those rare occasions when most people get my name right at the conference. So thank you for the invitation, and it's a pleasure to be here at my first KCD, almost at home in Prague. And today I'll be speaking about monitoring Kubernetes infrastructure with Prometheus and telemetry. We're going to take a look at their comparison, where they kind of intersect, and I guess we can try to answer the question, is this kind of a battle, is this a competition, or rather cooperation? So we'll be looking at the current state of both projects. We'll shortly look at what are their philosophies, where are they coming from, and how their state looks in current year, 2024. We will look at the overview of monitoring for both Prometheus and OpenTelemetry. We'll kind of look at how their model looks and how their inner functionings work when it comes to monitoring Kubernetes clusters. We'll take a look at some pitfalls. What are some things that you might need to look out for if you're using one or the other, or if you would like to migrate, and so on. And we'll try to wrap up with some conclusions from our learnings today. So maybe quick show of hands, who is already using Prometheus to monitor your Kubernetes clusters? Okay, so that looks like 30% maybe. Is anyone using OpenTelemetry? Okay, that's even 5% maybe. So how are you monitoring your clusters? What are other people using? Let's see. But anyway, why are we here today? Let's start from observability as a term. Why we need observability? We need to understand the state of our clusters, of our infrastructure, of our applications. We want to know what's going on inside of them, but we don't have magical glasses that we could see inside of our machines and read what's going on. So we need to somehow hook up our applications, our infrastructure, and see and export certain signals that will tell us what's going on inside. Now, when we're talking about monitoring, we'll be talking purely about metrics. So we will be talking about certain quantifiable values that we get out of the things that we monitor, right? And as we know, in the CNCF landscape, there are currently 2 projects that deal with monitoring. One of them is OpenTelemetry, which is like the new kid on the block, which is kind of the emerging cloud-native, kind of vendor-neutral way to do your observability. It's kind of it's a little bit more elusive to define it because it cuts through many different aspects of observability. Some of you who heard about OpenTelemetry might equate it to the OpenTelemetry collector, but it also includes its own protocol for transferring data, OTLP. There is a whole set of SDKs for different languages, APIs. There is a big specification that states how things should be implemented. So it's a big project that is really multifaceted, and it goes beyond really just beyond metrics as well, because it deals with all the major signals, traces, logs, metrics, and profiling is coming very soon. But it also has much richer or much more complex data model compared to Prometheus. And on the other hand, Prometheus, it's kind of more like a staple, trusted utility in the world of monitoring that we know. It has this also quite well-known exposition format that it uses. Also, a big part of Prometheus is the storage. It's time series database, whereas OpenTelemetry omits this part by design, where this is intended for your vendor to provide the storage. So there are some overlaps, but there are also some things that differ between both projects. And where are the projects in current year 2024? The way I see it, there is more and more interaction between the projects. There are people from both camps that are interacting with each other. So we have people coming from OpenTelemetry to Prometheus, but we have also many important people and core maintainers of Prometheus dealing with OpenTelemetry. And I think the biggest sign for that there is an interest in cooperation is coming from the Prometheus project and its members, who just recently declared their intent to commit themselves to OpenTelemetry, and seeing the adoption rates and the interest of users in OpenTelemetry to cooperate with the OpenTelemetry project and, for example, provide the missing parts that are not in OpenTelemetry. So, as we'll talk about it on the next slide. So, currently, OpenTelemetry, it's a little bit different story when it comes to its relationship with Prometheus, because from beginning, OpenTelemetry intended to support Prometheus as one of the major protocols out there. It was also defined in specification as such. It also has the notion of Prometheus receiver, which I will talk about a bit later, which basically enables you to use it as a drop-in replacement for a Prometheus instance. And there's also cooperation going on in the space of operators. And OpenTelemetry is also putting a lot of work into kind of a non-technical work, or work that's just outside of writing code and specs. So there is a working group for Prometheus. They are doing panels and surveys, and they really are trying to nail down the interests of users and their pain points and their and where they see need for help. On the other hand, as I said, Prometheus, there was this statement from the project about intention to support OpenTelemetry. For example, they want to be the default storage solution for OpenTelemetry, whereas, as I mentioned previously, OpenTelemetry by design initially did not include storage as part of the project. And there's also further work going on in trying to bring both closer together, since there are differences in data models and other issues stemming from the differences. So I think this is looking less as a battle and starting to look more like where we can cooperate, how we can fit in together, how OpenTelemetry, how Prometheus can fill maybe the missing gaps in OpenTelemetry, and how it can also support OpenTelemetry. If you want to learn more already today about each of those projects separately, you have opportunity to look at these talks from my fellow speakers that are on the program a bit later. So now let's look at the actual infrastructure monitoring and how it looks like and how it compares between Prometheus and OpenTelemetry. We're going to start from looking at what we actually want to monitor. In the simplest term, we will start by looking at our nodes where we run our workloads, because we want to know how is our node doing. So even the underlying structure, whatever it is, if it's running on a virtual machine, you want to know how is it, what's up with it, how much resources are being used. And you can keep adding on these categories, like you would want to know about processes, about networking, maybe about kernel. So we could probably add even more categories of metrics that you're interested in here. On the other hand, we also want to understand our workloads. So what is it that actually is running on my node that is already being managed by Kubernetes and it's part of my workloads. And we should also not forget that we also need to monitor the Kubernetes components itself. So here I put it under the host. I put there kubeled and kubeproxy. So we also need to make sure that these components are healthy and running without issues as well. So we have one node now multiplied by all the nodes that you have in your cluster, or even multiple clusters. On top of that, we have the control plane. So this is another part that we might need to focus on. Maybe depending on if you have a managed solution, you might find this maybe less important or interesting. But nevertheless, it should be part of your strategy or part of your thinking when you think about monitoring your cluster. And we want to also know about the overall state of our cluster, right? So it's not just these independent nodes or independent components, but we want to understand overall what's going on. So this will relate to different resources that you might have in Kubernetes, like you might want to know how many deployments you have and so on. And again, for the components, maybe if you on the control plane, you might want to know about how many requests there are to your Kubernetes API, there are any errors, what is the traffic, and again, like you want to know overall working of your components. So it seems like a lot. Now we want to have all of this information, but how do we get it out? As I was mentioning, since Prometheus is kind of the staple, the daily bread and butter as it used to be in the monitoring world, in the CNCF. This is also the way which Kubernetes decided to provide the metrics. So at each component, you will have a special endpoint /metrics where you will see metrics for that particular component. And this is a well-known format that is understood by Prometheus, and it's able to read this data and receive it. We'll look at it a little bit later, but if you're not familiar with Prometheus, this is how the metrics would look like if you opened up this /metrics endpoint, and we'll look at it a little bit later. So as I was saying, in the components we have the /metrics endpoint. There is one a little bit more special use case for the kubelet itself. It doesn't have only the /metrics endpoint, but on top of that, it provides certain extended metrics about more things that are related to your kubelet, or actually to your worker node. So, for example, the metrics /cAdvisor is quite useful because it gives you it gives you more information or more metrics about your containers, such as CPU, memory usage, disk usage of the containers. And this one is kind of baked into the kubelet, so you can leverage this as well for your monitoring. So this gives us a good starting point. As we said, we can use Prometheus who understands already this exposition format, and you can run Prometheus. You can deploy it on your cluster, or you can run it in as a stateful set, or maybe in a different configuration that is now not important. But basically, it takes care of you. It takes care of scraping this data in certain intervals, and then it either can store it by itself if you use Prometheus in the server mode, or as an agent, it can forward the data further to a different, you could use, again, you can use a vendor for your storage, or you might use a different project or a different storage solution that you run yourself. But this doesn't seem like a complete picture, right? We said that we need to monitor the individual components. We want to also look at what's running in our workloads, and we have this partially covered, but we're still missing the metrics about our nodes, so the stuff that's below, let's say, below Kubernetes. And we also don't have overview of the cluster itself, right? So how do we do that? Because these components do not expose any kind of /metrics endpoint. There are no standalone. There are not a standalone application, right? Your host. You need to figure out a way how to expose that information from your node, right? So for this, you need to run a separate specialized binaries that are called exporters within the Prometheus community. And they do exactly what I just said. So they understand the internal workings of whatever they are supposed to monitor, and then translate that information, those metrics, into format that's understood by Prometheus. So this then can be scraped just the same way as any ordinary /metrics endpoint would be scraped. And in our case, we are mostly interested in the node exporter. So this is one of the most used exporters that gives you metrics about your node. And you also have the kubestate metrics, which is kind of an add-on agent, a separate project that communicates with the Kubernetes API, and it exposes the metrics about the state of your clusters. And kubestate metrics gives you already quite a lot of advanced and detailed metrics, so it's quite powerful if you think about all the different objects you can have in your Kubernetes and what type of metrics you can expose about them. So it can also get very expensive. And with the node exporter, we will get information about our actual host, about CPU, memory, and so on, all of the groups of metrics that we set previously. Now let's compare this with how we would do this in the OpenTelemetry way. Kind of similarly to how Prometheus can be understood as an agent that sits somewhere on your cluster or somewhere near your infrastructure, and it's periodically looking at these sources and pulling the data from the sources. Similarly, there is a tool or binary or a project within the OpenTelemetry that is called Collector, and Collector's purpose is exactly the same. So it sits somewhere near your infrastructure and it's simply collecting the data. The difference, of course, Collector is has a much bigger surface because it also deals with other types of signals, so not just metrics, and it has some different capabilities than the Prometheus itself. So it has some more processing powers, and it understands multiple different protocols and formats. So you could also hook it up with, for example, StatsD or any other major protocol that is supported. So not only that, but Collector has a notion of receivers. And what are receivers? You could think of them as what I said previously in Prometheus exporters. So they are components within the Collector that are responsible for collecting data about certain particular component that we want to monitor. So if we compare it with Prometheus, these are not external binaries or external programs that you need to run separately, but they are part of the Collector itself. So it's all part of one configuration, one binary, and so you can just run it all in one container, basically, in the Collector. This will kind of be parallel to what we've seen previously. So you will have the host metrics receiver that will be collecting metrics about your host. We will have the kubelet stats receiver, which deals primarily with the kubelet metrics and pulls them from the kubelet API. And we have the Kubernetes cluster receiver that then deals with the whole cluster. So it would look something like this if we try to visualize it. So where we arrived, we've seen both Prometheus and OpenTelemetry, and we see how they can collect all of these groups of metrics. So we will know about our workloads on the nodes, we will know about our hosts, we will have understanding of overall what's going on in our cluster, about its state, and we will also monitor individual components within Kubernetes. Now, if we try to compare both a little bit, there are differences in the data model between Prometheus and OpenTelemetry. The major one that I'll show an example just in a moment is or one of the major ones is between the naming conventions and the supported characters, whereas Prometheus is quite limited character set, and it depends mainly on using underscore as a separator, whereas in OpenTelemetry you use this dot hierarchy, so the names will contain dots instead of underscores. And there are some more kind of advanced or more detailed differences in the data model, such as the OpenTelemetry has a notion of resources, which are metadata about the resource that originated that telemetry signal, whereas in Prometheus you would probably use this as a label, or you can sometimes have a special metric called target info. And also OpenTelemetry metrics is kind of a more complex type system, so it's not just counter gauge, histogram, and so on, but it's a bit more nuanced, and you can take a look at it if you're interested. So we'll look at a very practical example. We will want to, again, get information about our node, so we want to monitor our host, and we want to know how much CPU work it is doing, a very simple task. So if we look at the Prometheus, again, maybe if you went to the node exporter and you look at the /metrics endpoint, you would see, you would take a look at this metric maybe in your browser, so it's even human readable. You can see we have there some directives, the help and type directive that describes the metric and its type. And then we simply have the node CPU. It tells us it's in seconds, and the total suffix. It's also a kind of common way to denote this in Prometheus. And then we have the labels, which tells us which CPU this is, like physically or logically, and what kind of mode was the CPU doing the work. Now, if you look at the OpenTelemetry, since this OpenTelemetry doesn't have like a nice text exposition format, it's kind of harder to compare. You can run a debug exporter in collector that would kind of print out your metrics. But I think I just took this from the documentation, and I think we can already compare it and see differences. So this should tell you the same information, but as you see, it's the name of the metric is different. It uses dots instead of underscores in between trying to separate the namespaces. And there you see also the attributes below, so this will be included similarly to what we see above, right? So you have the CPU number and you have the mode of the CPU. So in that sense, they're similar, but not quite the same. Now, one thing that I didn't mention yet is about possibility to also use the Prometheus receiver in your collector. I was mentioning in beginning that you can use this as a drop-in replacement for a Prometheus. So practically also have power to use Prometheus agent or Prometheus way of collecting metrics that's baked into the collector. And again, it should work one-to-one with your Prometheus instance since it's intended to be a drop-in replacement. So again, imagine that you wanted to get some extra information from an exporter, or you would want to get metrics from the components themselves. You are also able to do it this way, right? So you can kind of what I named here, do a mix and match approach, so you could get some metrics about your cluster from the receivers. You could get other metrics from the exporters or the components themselves through the Prometheus exposition format. Now, when we look at some of the things that you should be thinking about when monitoring your cluster and choosing between these two. One important thing is with regards to kind of the extended things that come after you collect those metrics, right? You want to visualize them, you want to alert on them. And I think here is a big difference between how currently there is support in community. So in Prometheus, there are well-established projects and tools that help you to have a pretty good experience outside of running right outside of right out of the box. So again, you can use Prometheus as a storage. You have the alert manager. You have the mixin for your Kubernetes that will create the dashboard for you. And so this, if you do this by yourself, it's quite easy to do it for Prometheus, whereas for OpenTelemetry, right now you have to rely quite heavily on your vendor. So depending on their storage solutions, depending on their product, depending on what they provide to you, you are kind of relying on using them. And also, migrating might not be the easiest if you would consider migrating from Prometheus to OpenTelemetry, because as we've shown, if you want to use those OpenTelemetry metrics, there are differences in naming, there could be potentially differences in type of metrics. So we're monitoring the same thing, we get kind of similar metrics, but the naming will be different, and it's not guaranteed that even the values denoted are the same. So if you try to use a if you try to use Grafana dashboard for existing Grafana dashboard or the mixin for your OpenTelemetry setup, it would not work, right? It would also be like a breaking change for you. And yeah, the important thing also with the storage. So as I was mentioning previously, Prometheus intends to become a storage for OpenTelemetry metrics as well. It has experimental support, but currently you would probably, again, you might want to use OpenTelemetry if you have a vendor who supports it and who will accept the data in that format. Also, when looking at deployment modes and scalability, there are quite good ways to deploy the Prometheus project. There we have the operator, we have a quite developed chart, the Kubernetes stack, that focuses specifically on monitoring your Kubernetes cluster. And we have something similar that's coming up in the OpenTelemetry world, but it's still under development. It's not quite there yet. As I was also saying, there's difference between using these external components with Prometheus, so we have to run these extra exporters, so that's kind of extra overhead, extra binaries, extra pods, containers, whereas these are kind of internalized in the OpenTelemetry world. And you could argue there might be some kind of duplication of work going on because you're doing the same thing in OpenTelemetry as internalized, but in Prometheus as externalized. But in the end, you want to get the same or similar data. So that's another thing to consider. And also, one more thing is depending on when it comes to your experience, right? So with Prometheus, this is just one agent that's collecting metrics, but you might want to use collector if you also want to collect traces, metrics, and logs, and you want to have kind of a seamless integration or seamless experience, maybe for your whole team or company. Another important thing, this is why I was mentioning the possibility to scrape component metrics or exporter metrics with collector, because there are still some missing pieces in those native receivers, so you won't get the same, the surface of the metrics won't be the same between OpenTelemetry as we shown the setup and Prometheus as we shown the setup. But again, you can kind of, if you want to, you could mix and match this approach. So you could, for example, scrape the kube state metrics with your OpenTelemetry collector to get these extra cluster metrics that are missing. I think it's also important to mention in general, like the stability of the projects, and obviously Prometheus is a much longer project, has been in existence much longer. It's kind of much more stable. Also, the project maintenance is really well developed, although OpenTelemetry is doing a lot of work there as well. It has long-term support versions if you're interested in that. Especially with OpenTelemetry not having, like with the collector, it's still not being, at least with those extra components that we talk about, like the Prometheus receiver still and the Kubernetes related receivers still not being, in a stable version. There's potential for breaking changes happening between versions, which is not always nice. Also, I think it's also worth mentioning how do they compare with when it comes to resources, and this is something that also you might want to consider. Prometheus obviously might be more performant when it comes to collecting metrics. I've seen some talks and there are some information in the community about these comparisons, but I think there is more information necessary to do this, to properly compare both, and also take into consideration, obviously, that OpenTelemetry has a more complicated pipeline in the collector, and also the fact that you collect different types of signals besides metrics. So I think this is how we can wrap up most of these things I was mentioning as we were going. So I think OpenTelemetry might make sense if you're building something new, if you want to have a support, if you have a support from your vendor to do this, if you might want to unify the experience between different signals, or you might want to have the more powerful features that are provided by the collector. On the other hand, with Prometheus, this is something more stable. This gives you a really nice experience when you do it by yourself, including storage solution. And also if you have, as I was showing, maybe some need for more detailed or advanced metrics that you maybe cannot get from OpenTelemetry that easily. And again, it's a battle-tested horse, good performance, stability, support. So I think this gives you a good understanding of both. And with that, I conclude my presentation. Thank you. I don't know if there are any. Okay. Okay, in my company, if I didn't mention it, maybe I forgot in the beginning, I work for an observability vendor, so if you have a need, check us out. My team, we primarily work I work in a team that deals primarily with the agent side of things, so I help figure out configurations for our customers to how to use the collector, the OpenTelemetry collector, since that's our project of choice. And so I'm primarily using OpenTelemetry. That's what we're kind of what we're suggesting our users to use as well. That's kind of what we support. So that's mostly it from my side. It's OpenTelemetry. Previously, I was also involved in Prometheus and Thanos project. That's kind of extension of Prometheus. But I'm now mostly involved in OpenTelemetry. I don't use it myself for monitoring, but I help others to use it. And what is the future of telemetry collection? I think this can be a heated debate, but as OpenTelemetry is showing, you can do both approaches, or you can do the approach that you think has more advantages or disadvantages. So I think the answer would be both, or whatever you want.
Thank you very much. This concludes the presentation. 5 minutes break and we continue.
Thank you.
Máme mikrofon? Máme mikrofon. Okay, hello. I'm glad that we are here in such numbers. And now it's time for a story about exporting metrics and log from Prusa 3 printers. And split it into multiple parts, the good, the bad, and the ugly. Let's start. First things first, something about me. My name is Pavel Strobel, and also known as Pubel. Maybe you can see me like that in the internet. And I am DevOps engineer at Prusa Research. And my main focus is into observability and platform itself. And spoiler alert, we obviously use Kubernetes, because this is Kubernetes Community Days. Apart of that, I help with organizing of Cloud Native Prague meetups, where I handle mostly the social networks and AV stuff and streaming. Yeah, but wait, there's more. I like a lot of things, like 3D printers, obviously, and like printing the parts for my car, Angel Smart Electronics that you can control, and as well I can brew on my own beer. Now, what about Prusa Research? I told we use Kubernetes, but we are mainly 3D manufacturing company, right? Yeah, but not only that. We are running on Google Kubernetes engine, and at this moment we are running 2 clusters, staging and production. Clusters are pretty much stable. Situation 2 years ago was not as stable, but yeah, for now it's mostly stable. There's not that much updates like it was before, and those updates were very uncomfortable, let's say. We didn't want to have much hassle with on-premise or OpenShift. It can be nitpicky, so we choose the Google Kubernetes engine. Apart of Kubernetes, we are running multiple tools, like obviously Kubernetes, but also Argo. Argo is very popular right now, and we get why. We are one of the first companies in Czech Republic that embraced Argo in production. And apart of Argo, we use OpenTofu, or Terraform, if you want to call it like that. And we use Terraform or OpenTofu for deploying our internal tools, and that's mostly what we did with that. Our applications are deployed in GitHub base via Argo. Because Terraform language can be really interesting in some ways, we use Terraform to use nested folders, and we like to keep our code dry. We are also working on implementation of OpenTelemetry, which is now not working because there are no users that will use OpenTelemetry, but we have implemented the few demos, and hopefully in the future we will use it more. And let's talk about observability. For metrics backend, we use Prometheus, pretty used in the wild, so why not use it? But because Prometheus itself cannot handle high availability, we use Thanos for its federation and aggregation of the metrics. And last but not least, we are using Grafana Loki for logs backend, and yeah, at one time we were ingesting like 6 million log lines per minute because bug in one application, but it worked. Okay, this is very simplified developer pipeline that developers just get their code, push it into either GitLab, and if they add a tag, then it triggers CI pipeline in a GitLab, and it builds Docker image. Basic stuff, right? Yeah, there are several rules for staging and production clusters, but yeah, it just runs tests and creates the Docker image. Argo then, if it detects the new image, then it can be deployed into Kubernetes cluster, and based on the rules I said we have, it can be deployed or not. This is, let's say, observability pipeline, at least for metrics. As I said, we use Thanos, Google Bucket. In Google Bucket, we have metrics, and we use Thanos sidecars for Thanos. So Prometheus automatically sends the metrics into Google Bucket. Yeah, and Prometheus working on pull model is pulling the metrics from our applications and our internal stack, etc., etc., etc. And why is the scheduler there? The scheduler there is because our Thanos sidecar was consuming more than, not more, almost double of the memory that Prometheus itself used. It was, we had 24 gigs instance of Prometheus and 44 gigs instance of Thanos sidecar. Very nice. Yeah, but if I told you that you can observe also our 3D printers with Grafana, Prometheus, and Loki. Okay, first, the good. It's the idea of creating Prusa exporter. What is Prusa exporter, you ask? It's not Joseph exporting you. It's about exporting Prometheus type metrics from our printers. But what is Prometheus, you ask? I will give you a quick insight. Prometheus is a metrics backend. You store metrics in there and you can get metrics from there. And it's also pulling metrics from the endpoints. That's basically what it does. Prometheus type of metrics is text file. Yeah, basically, it's, at least for now, it's text file. It wasn't always in the past. Prometheus mostly use pull model. Pull model just scrapes the data from the endpoints and store them in the internal database, the SDB. You can use actually even push model. It's called remote write, but that doesn't work. Don't work that well. But you can do that. You can really feel that Prometheus was made in the pull model in mind. Yeah. I forgot switching the slides. Okay, but what's these, you ask? These are, those are dogs. No, those buddies. Those, what's this, not cars, motherboards are called, because buddy was Joseph Puk, and developers of the motherboards for the printers named the board buddy, so it's basically dog. And there are three. There are original body, there are X body and XL body. What those boards have in common is the CPU. It uses STM32, and what they have in common is lack of processing power. Yeah. So though cannot expose metrics alone, you need something else. Why not use Raspberry Pi? Raspberry Pi is pretty much known, can run Linux, you can write export in there and scrape the metrics from printers. Okay, fine, let's do that. And by the way, you can add printer support for SL1 or MK3, MK2, and that's the advantage of having an excellent device. The bad, the execution. At the start, we have those 3 printers. Yeah, let's call them buddies. Those buddies expose metrics in PrusaLink format. PrusaLink is a local management tool that runs inside of the printer. You can control everything you actually can, and it's not connected into cloud. There is also, let's say, syslog metrics. And those are metrics in line protocol format, but it's not pure line protocol format because lack of the processing power causes that printer cannot send a proper timestamp. It uses delta timestamp. The issue is it's not ingestible by influx and not ingestible by anything. So you need some kind of man in the middle that get those metrics, recalculate the timestamp, and send them there, send them somewhere else. Okay, this is my black box. I was thinking, I can use InfluxDB, yes. do I want to use InfluxDB? No, I don't want to use InfluxDB. I'm not a fan of this technology. Okay, what I wanted to use is Grafana. Grafana is pretty well known as well. I'm familiar with. It can be hassle sometimes, but yeah, mostly it works. And you can create your dashboards as well. You can use Prometheus Influx as your backend, Loki or Elastic as your backend for logs, etc. So why not use it? I won't use Prometheus, as you can see, and Grafana Loki. So basically, I just took our internal stack and put it in the Docker Compose. Okay, I chose those three technologies. That's fine. That's fine. Now I need to choose programming language because it was a while back that I wrote any more like 100 lines of code. So I was thinking. I knew C#, so C# was a pretty viable option, and yeah, I loved it on my list. I knew JavaScript. It's an option, right? No, it's not. I don't want to use the JavaScript, but I wanted to mention it. I wrote my bachelor thesis in C++ back in the day, but it didn't felt right using C++ for this kind of project. So I also was thinking about using Python. Yeah, this is kind of project that Python will use. Why not? And also, why not use something that I don't know, learning something new, Golang. Yeah. And C# was gone. I don't want to use C#. It's too heavy for this project. And we have on the list only two languages, Python and Golang. And Golang won. I choose Golang. Okay. Now it's time to think again. Who is my target audience? That's not an easy question. Maybe schools? Maybe. Maybe our fans? Who knows? Some fans have like 20 printers at once, and observing them will be much easier via one tool. You can use Prusa Connect, of course, but the issue is then you have to be connected to internet. So it's not always possible. So this is one kind of things you can do. It's locally. Maybe people just like observability, like me. Why not? Just you look at the data. It's cool, nice. Honestly, I didn't know. I just wanted to start coding, so let's get this shit done. Okay. And I need to switch, yes. I started with Prusa metrics. Those are available via REST API, in JSON format, pretty normal, and that's fine. I can work with that. And for now, leaving the syslog metrics for later. Yeah, I was thinking. But that was not good idea, because I just decided to reinvent the wheel. If you are familiar with Prometheus ecosystem, you know there is something called JSON exporter that basically does what I did. So I just created JSON exporter from scratch, and yes, it works. Was it a good idea? No, it wasn't. But yeah, it was fun at least. Okay, we have Prusa metrics. Now it's time for syslog. Syslog metrics are sent via with UDP in mind, and as you can say from the image, sometimes you get the UDP, sometimes not. Printer is not able to handle a TCP. Data are sent like in 100 millisecond interval, and if you want more data, then then the interval is much faster. If I remember from my limited testing, let's say, so I just implemented my own syslog server. Well, no, I used library. I wanted to have it fast. and cheap and dirty. So I just used a library that works pretty well. It handles RFC 54244. Sorry about that. And yeah, that's everything I needed. Okay, we have metrics. And now we know we need some kind of dashboards. Dashboards are, there are multiple dashboards I created. There are example dashboards. You can use the data from the dashboard, panels from the dashboards to create your own. With Blackjack, of course, as you saw. And this is basic proof shelling dashboard. And proof shelling have pretty much basic metrics. Yeah, you have temperature, you have what you know what you are printing, etc. But more interesting are syslog metrics, because you have information about not only what you are printing or temperature, but also about current voltage the printer is running on, about the logs, because you are using logs. You can get the logs from the printer. Pulse width modulation for multiple devices in the printer. And there's much more that you can just visualize, but it's upon you what you want to see. Yeah, and as well, you can also create this kind of overview dashboard if you have more printers. You know what is printing, what is not, what is an error state, etc. The ugly, the aftermath. Yeah, I like saying that I like messing with things, so my code is kind of messy. A lot of versions 1.0 not is final. I need to still fix a few issues and create a unit test, you know, that issues. And then maybe it could be distributable. Also, testing Raspberry Pi image is not viable with manual testing, so I need to get it there. And of course, being this my first Golang project, at start it was real messy. Now it's a little bit better, but still not good. Yeah, I'm kind of roasting myself. Yeah, but the point is that you should be aware that any language have its quirks and features, and working on your personal project can be absolute blast. Well, it's absolutely worst. Can be really painful. Constant refactoring, thinking how you can do better. Yeah, those are good things, but you need to have some kind of self-control, which is very hard. Also, getting into new language can be difficult, as it was while I wrote more than that. Let's say more than 100 lines of codes, and a lot of times I was feeling like this dog. But in the end, I'm glad that I did not choose Python over Golang. Even Python is a good language. Golang is much faster for this kind of application. Yeah, and Gopher is kind of cute, isn't it? Yeah, having 500 lines of code in one file is not that nice. But anyway, yeah, the use. I will show you how the Prusa exporter is used in the wild. Grafana Labs somehow, I don't know why, really like to use our 3D printers as demonstration of monitoring. Something different than, I guess, Node exporter. This is KubeCon 2024 in Paris, and we also have been at FOSDEM in Brussels this year. And not only there, this is first demonstration of the exporter, and it was in PromCon, at PromCon 2023 last year. It was some kind of pilot, but yeah, the pilot works pretty well. But yeah, getting into Berlin after meetup wasn't that nice. And this is GrafanaCon in Amsterdam. People were very interested in the 3D printer and 3D printed parts. They were printing coins with Prometheus logo, and yeah, and also observability side of the things. And the future is big unknown. Yeah, I can always switch to influx, but the point is to not use influx. Yeah. However, there is one thing I can use from the influx, and it's line protocol. Yeah, there's more. I wanted Prometheus metrics exporter, and that means you have slash metrics, right? Not always. You can use influx to Cortex proxy that gets the metrics in line protocol and pushes them, use remote write for in Prometheus and sends the data in ingestible format for Prometheus. I already tested Mimir. Grafana Mimir is the implementation, let's say, of Prometheus at Grafana, and it worked. It's a fork of Cortex. And yeah, okay. And next thing is OpenTelemetry I want to mention, because OpenTelemetry is the next big thing. We are embracing OpenTelemetry and kind of at Prusa research, and it's next big thing in observability, I think. But we need to research this field more, and I don't know even if it's viable for this kind of project. Yeah, as I said, the issue is that printers sense a lot of data very quickly. This is video where this start, printer sense its standard set of metrics. It's not that much metrics, like CPU usage, heap usage, not even temperatures, but some kind of metrics, yeah. But I want all the metrics. Yeah, standard set of metrics. And this is one printer. Just imagine you have like 20 or 50 or 100 or few hundred printers of what it can do to your network. This is fine. Remote write is fine. I said that I tested Grafana Mimir. Mimir was fine, but I want to use Prometheus. I need to test it more. And it's a question if it's able to handle it. The demo, it's demo time. I am lying, I don't have a demo. There is a live demo running at our Prusa booth, and you can see Prometheus Prusa exporter up and running Grafana Mimir, Grafana Loki, and Grafana itself. Take a look there. Okay, and it's the end. It's time for your questions and hopefully my answers. Am I right? Okay, I have questions. Why did you choose OpenTofu technology over Terraform? Well, we used Terraform before OpenTofu because we are running our cluster 2.5 years. Yeah, 2.5 years, and after really changing the license. You probably heard of, we just decided to try OpenTofu. Why not? I tried it in beta version, it worked somehow, but now it's pretty much stable, and it wasn't something we have to change Terraform to OpenTofu, but we just wanted to. And I was able to make it through. What are some other weird contraption you wrote a Prometheus exporter for? Do you export OBD data from your car? No, but I bought a car for exporting OBD metrics from the car. And I have a project in my mind because I'm attempting race days at or track days, and I want to have data from the car in some kind of, let's say, detailed form with other sensors like acceleration, etc. Okay. Do you have any other questions? Yeah, we do. What is your biggest surprise start using Go? The syntax. It's not I was used to, because I was used to have like data type and the name of the variable, and now it's now the variable and data type, which was probably the biggest issue. The biggest issue I had, but yeah, mostly it's most of the programming languages are the same, just the syntax is different, but it has its quirky features. Go routines are awesome. I really love them. Yeah, that's probably the most interesting things I can say. Okay, how do you use Thanos? We have two instances of Prometheus at staging and at production. And we use the Thanos as an aggregator of the metrics because we have Thanos connected to Grafana and we query the Thanos instead of Prometheus itself. That's how we use it, and of course for long-term storage. We have over 2 years of data there, and that's how we use Thanos. How do you manage your Kubernetes deployments? Native YAML manifest or some extensible approach? We use Argo for deploying our applications, and we use Terraform for deploying the internal tooling, and we use Helm charts. Obviously, we use Helm charts that somebody made for like Thanos or Prometheus or Loki or Grafana, and we write our own Helm charts for our applications. You can ask, actually, there is a Philip that made this possible and created most of the Helm charts we are running right now. And yeah, that's probably everything I can say you, tell you at this moment. Okay, I guess that's it. Thanks for attending and see you later.
One. Hello, everybody. My name is Andrei Kvapil, and today I'm going to tell you about Kubernetes, that it is new Skynet or rise of Kubernetes automation. Few words about me. Can we see my slides, please? Thank you. I started my Kubernetes experience working for Vedas. This is biggest Czech hosting company. I was doing automation for a lot of servers, hundreds and thousands of servers which were put into the oil. That was quite exciting job. I was automating the bootstrapping of these servers and running Kubernetes on top of this. Then I switched to work for Pelark. I was developing Kubernetes platform which is called Deckhouse. I bring virtualization based on KubeVirt and storage based on LinStore there. And since 2023, I founded new company, and now we are focusing on providing open source solution for making managed services. And this presentation is more about how we build platform and about open source technologies used to build this platform. My presentation can be split to 4 different parts. The first part will shed a light what the problems and what the challenges have to run Kubernetes on-prem installations. Let's have a start. Do you like to use Kubernetes in the cloud? I guess yes. But there is no cloud, it's just someone else's computer. All joke. When you're using Kubernetes in cloud, you're actually acting just with this part of Kubernetes, the user part, which includes APIs, and you don't worry about this bottom part for bare metal. You don't worry about virtualization, networking stuff, how you configure routing, how you bootstrap your servers. That's all the part is done by cloud provider. Today I'm going to tell you about this part if you would like to create your own Kubernetes cloud and if you want to provide Kubernetes as a service. When you're using Kubernetes in cloud, you usually see this scheme. When you have Kubernetes control plane, so you're acting with Kubernetes control plane and all the rest part is somehow separated. So you have separated worker nodes, separated load balancers, and what is more important, the data for your application stored externally in outside storage. This works well, so you can scale it, you can scale down, scale up by creating new nodes. You can even remove all the nodes of your cluster. The data will be stored, then externally, then create it again. Your application will start acting as it was before. Load balancers will just change in points, but finally your application will be continue working in Kubernetes as it before. But how you can make your own cloud? When we're talking about Kubernetes and bare metal, usually people have few options how you can do this. The most common option which people to consider is to run Kubernetes right on bare metal nodes. In this way, you can have some bare metal nodes and you can install Kubernetes the normal way, like using kubeadm, kubespray, or K3s, any tool you can use for this. But instead of this amazing scheme, you will get this scheme where all services packed together, and it has some problems. For example, you have no convenient management for this. The updates are painful because not every application is prepared to recreate nodes to shoot it down, so you have to be prepared to this. There is also no autoscaling and no multi-tenancy. I would say hard multi-tenancy because Kubernetes was never designed to be a hard multi-tenancy platform. The second option, which people usually to consider, is to use OpenStack and run multiple Kubernetes clusters on top of this OpenStack, or you can use any other cloud platform which you can install locally. But in this scheme, you have also a big problem that you have another stack of technologies which you have to worry. You have to have specific infrastructure team which will support this. This is typical scheme of OpenStack, which is really difficult to maintain, to update, and to keep updated. And the third option is quite new, but I would say right now it is already, Kubernetes is already prepared to run other virtual machines and other clusters. In this way, we just throw away this OpenStack layer and replace it with pure Kubernetes. And you can run other user tenant Kubernetes clusters on top of this management Kubernetes cluster. So let's put terms. Management cluster, when I will talk about management cluster, that will mean that this is a cluster which running on bare metal. And we also have tenant clusters, which means user clusters. They run in virtual machines on top of this management cluster. The benefits of this is same ecosystem. You can use the same tools like Helm or kubectl to configure your Kubernetes, the both of them. You have hard multi-tenancy. You can really create separate clusters, and users will not even know that they're existing in the same system. And tenant clusters have the same, they implement the same cloud pattern. So you can autoscale, you can have separate load balancer and store data externally. So your application will always prepare to be working the same way like you're deploying in the cloud. You can same way install it in tenant cluster and expect that all the features will be working. The management cluster is still a little bit different, but it is limited to specific services running on it. So we can be prepared these exactly clusters and all the services running inside of this prepared to work in this way. It is actually responsible just for a few things, for providing virtual machines, for running Kubernetes clusters, databases, and queries as a service. And this way, we decided to make a platform. Our open source platform allows you to simply swap your bare metal servers into this system where you can order every specific service you want to. It has this nice dashboard where you click and install some applications the same way you'd use, I know, Apple Store or something like this. Every application, every tile on this dashboard can be configured with UI, but after all, it is just a values file for Helm charts. So you can extend it even by adding your own applications, but it is still managed by operator approach. And by talking about this platform, I would like to explain how it works on every layer. The first layer is system layer, how you run Linux and how you run Kubernetes. And we use Talos Linux, so I'll explain how it works. The second layer is storage. We do use LinStore. This storage provides, this is also open source technology, which works in kernel. It provides really high performance, but it depends on specific kernel modules, and it requires operating system to be configured the right way. For networking, we use OVN, typical technology for virtualization in OpenStack, and for virtualization, we also use KubeVirt. On top of this, we have third layer, which installs operator, cluster API, monitoring. And the fourth layer is user-side applications, how they order managed Kubernetes and databases as a service. The second and third layer also managed by FluxCD. I'll explain you how it works. But first, let's talk about the first layer, how you can simplify the installation of the operating system and running Kubernetes on-prem. Let's switch to the second part of my presentation, how we prepare hardware and OS layer. As I told you, we use Talos Linux, and let me explain you how exactly it works. Let's say you have infrastructure. It can be virtual infrastructure, virtual machines running in a cloud, or virtual machines running on bare metal, or bare metal servers itself. It doesn't matter. If you see download page in Talos Linux, you can see that it has images for every typical system which you can just download and start using. For example, there are images for Proxmox and OpenStack, there is also more generic way for installing using ISO or PXE. You can also run it locally using Docker. So it's like kind replacement. You can even try it on your local laptop, for example. But anyway, to bootstrap the cluster using Talos Linux, you have to boot Talos Linux image on your virtual machines and your servers. How you do this is not important. Let's say you have virtual machines which are running Talos Linux without configuration, maybe a short configuration of networking. But after all, to configure every machine, Talos Linux has single YAML file. So you can use single YAML file to configure whole system and your cluster. You just have to apply it using kubectl apply. Talosctl apply. Let's see how it works. This configuration file holds few sections, actually two. Machine section, which describes specific configuration for the nodes, for every node, and cluster section, which describes configuration for entry cluster. Machine section includes such options like type of machine. It can be control plane, either worker. It has certificates, also network configuration, and disk to install. The cluster section has options to describe how you can access Kubernetes API, the same certificates for accessing Kubernetes API, and some options to configure Kubernetes components. So you have single configuration file describing how it should work, and you just apply it to the virtual machine using talosctl apply command. After you apply it, it starts working. If you want to bootstrap the whole cluster, you can use the second approach. You just generate secrets, talosctl again secrets. In output, you get YAML file, which holding all the secrets for your cluster, which is really convenient way you can encrypt it and store it in Git, for example. Out of this file, you can generate few more configuration files. For this, you run talosctl again config with secrets, and you got 3 more files. Talos config, it's similar to kubeconfig used to accessing Talos API, and control plane is configuration used to configure your control plane nodes. Worker as well for configuring worker nodes. Then you do talosctl apply and applying this configuration file to every node. After all the nodes configured, you run talosctl bootstrap, which starts etcd cluster and magically join them together into Kubernetes. Okay, when you applied your configuration, you might want to update some node in the cluster. In this way, you just apply new configuration the same way like you applying deployment into Kubernetes, the same way you applying this configuration to the one of the node and run upgrade command. This node itself will take a lease, drain all the workload out of this, then shut down, upgrade the image, and turn back to the cluster. This is how it works. To access the cluster, you can use virtual IP configuration, which implements floating IP. It looks like VRRP, but it's checking its state based on etcd state. So it works only on control plane nodes. Then you use kubeconfig file to accessing this cluster, and this IP can be swapped to the node. So when you put some nodes into maintenance, it will be automatically moved to another node. Looks very simple. I guess not very, because it is new pattern, and we understand user needs because we're trying to to keep user experience similar to experience they have. So we developed our own tool for which automates this. And it looks like old school Debian installation method. Let's say you have some servers. We provide 2 Docker images, GCP server and PXE server. And we have also installation tool which called Talos Bootstrap. The nodes can be booted out of the nothing just from these 2 Docker images. So they will put it into Talos in maintenance mode. Then you use this tool for creating Kubernetes and configuring your nodes one by one. How it works? When you run this tool, it finds all the nodes you have in your data centrum. You choose the node, put host name, choose the disk to install, put network settings, and finally you have the same Talos configuration file, which is just applied to the nodes. Then you click next, 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 and in a while you have ready cluster just in 5 minutes. If you look inside, we ship our platform with pre-built image, which holds all the needed firmwares for every hardware, and it also includes specific specific kernel models we use. It is DRBD and ZFS for our storage, and they're also running it this way. So this part is table base for building our platform. Let's talk about the second part, layer 2 and layer 3, the system components. If you have a ready Kubernetes cluster, you're free to use it, but you have to configure it somehow first. You have to install cert manager, CNI plugin, monitoring, all this stuff which you get used to install using Helm. And in this way, I would like to say that Talos Linux works well with FluxCD because you can configure, describe your configuration in Git repository and just put Flux, which takes these components and installing into the cluster. Even in Talos configuration file, you have extra manifest section where you can specify that Flux should be installed and YAML, which describes your configuration for the cluster. We have a little different approach because we build platform which is box solution, and we want to make it independent to any Git repository. So we ship all the components together with the platform. How we implemented it? We let our user to install platform with cozystack.yaml, which actually creates just a container, which includes all the Helm charts needed to be installed. It's just Helm chart museum with set of charts we ship with the platform. This container also installs FluxCD, and FluxCD takes all these Helm charts and installing in the cluster. If we want to update our platform, we just let user to run new container, then Flux updates those components. Very simple. This way we deliver our storage, networking, which is multi-tenant as well for make virtualization works, and monitoring. And now the most interesting thing, how we do managed Kubernetes service. Managed Kubernetes, we provide the managed Kubernetes on-prem, which holds all the things you get to use in cloud installations. The same load balancers, persistent volumes, and cluster autoscaler. So we use Kamaji project. Kamaji project allows you to run Kubernetes as pods, so you don't have to have specific virtual machines for your control plane nodes, and users never see their control plane nodes. It's because Kubernetes is just service, we run it as same application in Kubernetes. Kamaji can provide control planes for multiple vendors like VMware, AWS, but we use KubeVirt provider. And we use Cluster API to orchestrate this. We are going to add support for multiple clouds. But right now we provide a ready system which works just out of box with KubeVirt. So if we're talking about Kamaji architecture, there's two things which you have to think. There's actually CRs. Tenant control plane, which creates set of pods holding API server, control plane, scheduler, and controller manager, and data store where it stores. Usually etcd, but you can also use Postgres with project which transforms Kubernetes APIs. So by the way, as I told you, all the applications we provide is just Helm charts which putting YAML configuration to the cluster. This YAML describes new Kubernetes cluster have to be created, and it spawns the next resources cluster, kind cluster, Kamaji control plane, and kubevirt cluster. It also creates node group. Node group creates machine deployment, and it also creates kubevirt machine template and kubebud config template resources. The first one is managed by control plane provider by Kamaji. The second one is managed by infrastructure provider, kubevirt, and the next kubebud config template managed by Bootstrap provider, which provides and generates configuration for joining nodes to the control plane using kubebud. If we'll dig deeper about machine deployment resource, we can see that same similarity how it works with Kubernetes deployment. So machine deployment creates machine set, and it creates machine, and every machine is just virtual machine, which is worker for our newly created cluster. This is how it works. And as about databases as a service, we use standard operators. You can see them on the screen. So when you install some application from the dashboard, the new Helm chart is created, database object, and this object is managed by operator. For example, if we're deploying Redis, you can specify that you need new Redis database, and you specify this small amount of parameters. It creates free YAML files, like Redis failover, service for connecting to it, and scraper for collecting metrics. This way, we implement the system which allows to run managed Kubernetes, managed databases, even virtual machines, and some other extra services. What about multi-tenancy? That's also an interesting topic. We built our system to not let tenant clusters access management clusters. If you use cloud, you usually see that there are a lot of service components which acting with cloud API. For example, CSI driver or cluster autoscaler. We have these components outside, and they connecting to tenant cluster. And inside of tenant cluster, user can go outside and to access any API of management Kubernetes cluster. So when user is querying, ordering new service, it goes to your website or to your web portal or your Git repository configuration, or it can access directly the servers he ordered. And as about multi-tenancy, we implement the same pattern like Linux kernel namespaces work. First, you can create tenants nested, and by default you have tenant root, which have domain assigned, and when you create new tenants, the new subdomain get assigned to them. Inside of these tenants, every tenant is namespace, Kubernetes namespace. But there are some namespace services attached to this namespace. Those services are etcd, monitoring, and ingress controller. It is allowed to create new tenants, and you can specify specific services you want to assign to this tenant before applications will be created in this tenant. But when you create applications, they are using the same services of upper tenants. For example, you can create few Kubernetes clusters, and they will use cluster etcd and common monitoring of upper tenant. This scheme is very useful in case if you want to provide user the single Grafana, where he will see all services running in other tenants created and provided by him. So, conclusion. We got the system which allows to create environments which are highly reproducible and very unified. We always have the same kernel modules, and versions are hard-coded. So we can use it for everything, for running all the cluster services. We have simple interface for installation, which not breaking user experience. And our platform covers all the infrastructure stack which you need to build your own cloud. It is easy to extend, so you can put your own Helm charts with your icons, description, which will just put needed amount of YAML files into the cluster, and we are open source. If you want to, you can find it on GitHub. Please give us a star. I'll provide you links to Cozy Stack platform, and the technologies I was talking about is Talos Linux and Kamaji project, which allows you to run Kubernetes in pods. Final link is to Kubernetes blog, where I described how it actually works in written form. Many thanks to people who helped me to prepare this amazing presentation, and I'm ready to answer your questions. The question is, what is the main difference with D8S? Unfortunately, I don't know this solution. I can't provide you any information. I'll take a look. The second question is, you showed that install CNI using FluxCD. How it is possible to use FluxCD when you don't have CNI? There is a mode how to run Flux on host network. There is some options how you can run Talos with host network, but we don't use this approach. Our platform ships with small bash script in 50 lines of code. It also initially installs CNI and installs FluxCD, and then it expects that all the REST components will be installed in FluxCD, using FluxCD. The next question is, can you explain more in depth the bootstrap process under the hood where Flux is being used, and what are the core components bundled in chart? I was talking about this in this slide. So Helm chart is just a tool to put YAMLs into the Kubernetes. We still use operator-based approach. We just need to combine some set of files and provide smaller configuration for the user. So we provide small configuration. We can track it. We can check it with OpenAPI spec. We can provide some description for every parameter. But finally, it creates just few YAML files, which are managed by operator. Okay. I didn't answer how the bootstrap process works. There is small bash script. It runs creation of Flux, creation of CNI, and then we are expecting that all the components will be installed by Flux. The question is, each tenant is separate Kubernetes. No, tenant is like basic entity, security entity in our system. You can use tenant, and inside of tenant, you can create multiple applications. It can be Kubernetes, or it can be Postgres. It's not important. You can run whatever you want. You can even run few Kubernetes clusters in single tenant. Yeah, the question about DeckHouse. I was working for a company who was developing the DeckHouse, and I can explain. DeckHouse covers a little bit different stack of technologies, and DeckHouse provides platform for easily using Kubernetes, but it not covers this stack of preparing managed services. So our idea is using managed services, and we want to provide managed services for service providers. Yes, Cozy Stack can be used as Kubernetes distribution, but this is not main goal. The main goal is managed services. The question is, how's the compatibility with NVIDIA GPUs support when the Kubernetes is running on top of Talos OS? To be honest, I haven't tried. I tried using KubeVirt with NVIDIA drivers, and I saw that there is some implementation for NVIDIA GPUs in Talos. You just have to build your image with specific system extension which will put all the needed kernel modules for the NVIDIA. This is important thing to know about Talus. So if you want to customize the image, you have to build your own. You just specify needed components needed to be installed. You can even use factory Talus dev, where you check mark all the extensions you want to, and output you get the image you can boot your nodes from. And this image can include all the needed drivers for NVIDIA GPUs. What is inside? What about Kubernetes? You just install this NVIDIA device plugin, if I remember it correct, and it will work. I expect it will work as usual. Is there any other questions? Maybe in auditory? Okay then, thank you.
Hello, everybody. We will talk about the microfrontends and microservices and how you can actually use microfrontends with Kubernetes. I'm Milan Unger. I work in Siemens Healthineers as senior key expert.
I am Michal. I'm also working in Siemens Healthineers, and I'm a test architect currently.
So let's start with the definition. So if you hear about the microservices and microfrontends, they are now quite common buzzwords. And if you look at the definitions, you will find it sounds very similar. So they are encapsulated, they are small, focused, and you can use them to decompose your solution, and you can use them as loosely coupled components to build a bigger architecture. But when you look how you use it, there is quite a difference. The microservices, you will use Kubernetes, you will use Docker, you will use GitOps and DevOps. That's something which we all know, at least if we are moving in the cloud native world. If you look at the microfrontends, then you have a lot of the possible ways how to deploy it. You can integrate it in the compile time, you can integrate it in the runtime, you can deploy it through the CDN, you can build it in using the NPM, or you can use the backend Docker container for your microfrontend. So if you really want to build a system which is built from the microfeatures, what you actually want is to have the vertical microfeatures. So you don't want to have one monolithic front end which then communicates with a lot of small micro backends, because that will lead to the situations where each microservice is already ready, but the monolithic micro frontend is like behind the schedule. So we would like to have really the vertical microfeatures, you would like to have independent release cycles, and you would like to have independent teams, and both on the front end and the back end. So the question is actually how you can bring the functionality of the back end in using the Kubernetes and using the GitOps also to the micro front ends world. So really have the similar approach for the front end and for the back end. So that was basically the problem we were facing a few years ago. Our company has collaboration with the Slovak Technical University, and here we are having the lectures where we try to teach students how to build modern cloud-native full-stack solutions based on the microservices and 12-factor applications. Part of the goal of the students is to deliver semestral project. You have now around 50 students which needs to deploy their microfeatures to common solutions. So for the backend, it was quite clear. They will just deploy to the GitOps some microservice, some Docker and Kubernetes manifest for the backend. But for the front end, it was quite challenging how you will actually integrate 50 different features into common solutions to really keep the main idea of the microservices on the back end, also on the front end, and at the same time keep every student or every project of the student independent, so they are not depending on each other and you cannot then evaluate the work. So our solution was Kubernetes controller, which we used to orchestrate the micro frontends, and we name it Polyphia, and I would like to ask Michal to continue.
Yes, so the Polyphia is not just the controller. As you know, if you want some UI, you also have to have some libraries in the front end. So we see the link is there for our GitHub. We have multiple repositories there. One of them is also a shell that can display this UI, and also a JavaScript library that actually communicates with the controller to display all the web components. So what is the controller actually? How does it look? So it's implemented using Operator SDK for its simplicity, and it's written in Go. The reason why I'm mentioning it here, because the first version of this that was created 3 years ago or so was written in Prolog. I'm not sure how many of you speak Prolog, but I didn't. So it was hard for me to describe anything to the students or help them with any bugs. But thankfully, the GitHub Copilot speaks Prolog. So I just asked him, please explain this code, and I started rewriting it in Go. But the problem with that is that it ended up being some sort of combination of Prolog and Go. It was just Prolog rewritten in Go. So we decided with Milan to create the new version and also refactor the custom resources a little bit. So we have 3 different custom resources. One is micro frontend class, one is micro frontend, and one is web component. So let's look a little bit more into details. So here it is. I hope it's visible. This picture depicts how the different custom resources are actually mapping to the UI, right? So we have the micro frontend class, which is basically the entry point to your single page application, and our controller can handle multiple micro frontend classes, so you can have multiple applications basically under it. Then we have something that we call micro frontend that is basically, you could summarize it as a reference to some service that is then serving your web components, right? Or the bundle that is having these web components. So it's not really like visible anywhere, but it's required for us to know where to load the web components from. Then we have the web component itself. That is again visible in the UI. You can see those arrows. There are 2 arrows right now because you can see in this shell that we have. This is a material design shell. Currently, we have some context there, and we can put the web components into different contexts. One of them could be this application with this nice icon and everything, and one can be in this railer. Let's go a little bit more into details. I'm not sure how much the code is visible, but you can find this presentation also on the GitHub if you want to have a detailed look. So the micro frontend class is actually, as I said, the entry point. What you can specify there is the base URL for that application and some other metadata for it. Like, for example, CSP header for security, and also things like some additional headers, if you want progressive application enabled and things like this. So it's all handled then on our side. Yeah. Then we have the micro frontend. Here you basically just reference the backend that will serve the individual bundles and the web components in them. So if you have a look at the example, we have some reference for micro frontend called Polyphia MD shell, which stands for material design shell. You can see that for this micro frontend, we want it to belong to this FEA frontend class. So there is sort of grouping, right? So if you request the base URL of FEA, then it will only load the micro frontend of that class. Then you have some service reference. This can either be internal service inside of Kubernetes or and some external side also. Then there is a different option that you will have to disable where it's not proxying through our server. Then you have the module path that you want to load, and you can load multiple modules from the same service, but you would need to use different micro frontends. You can also specify some dependencies. So for example, our material design shell is dependent on material design web components, right? So we have an additional micro frontend there defined, and that's the material design. In this case, it's still served from the same service, but it's a different bundle. And one specialty here is also that you can specify some static files that needs to be loaded before the module. So, for example, some fonts or some style sheets and things like this. There are a lot more options, but this is like a simple example. Then we have the web component itself, as I was also pointing with the arrows at the same web components. So this Saturn is one web component. It is using, again, this Polyphia MD shell micro frontend, and it is looking in this bundle for a web component named Polyphia MD app. It has some attributes. It's just regular HTML element attributes. Like if you were putting it into base HTML, you can define any attributes you need for your implementation. implicitly, it also receives the context. And then you can specify where it should display. So we have some sort of display rules designed. We have 3 options. It can be either any of that you specify there, all of, or none of. So this way you can combine it really and put it into different contexts. So in this case, for example, the middle one is the application context, and the left one, the Railer, is the Railer context. So that's why you can see the 2 instances of on that web component. And because of it receives this implicit context information, you can also then change how the web component is displayed when you're displaying it. Yeah, and again, maybe one slide back, there is this href that says what should happen when I click on this tile or on this icon on the left. And it will redirect you to a different URL, basically. And here is another example of web component where you specify the display rules that the path need to match the Saturn path, and then it will load an image. So this is, again, some, well, not specific use case, but another use case of it. You don't have to load the element from micro frontend always. So you can either have it preloaded, or you can use native HTML elements. Like here we are using a default image. We just specify the source of the image and some alt text. Yep, back to you.
Okay, so let's speak about the features and use cases which we support. So first thing is that now you can use the Kubernetes manifest and you can use the GitOps. So basically when you want to deliver the micro frontends and compose the sites and you would like to add additional features, all what your team need to know is how to create a Kubernetes manifest, and you give him some GitOps options. So for example, in his lectures we use FluxCD and let the students actually define manifest in the GitOps way using the FluxCD infrastructure. Once you deploy the Polyfy, you will get automatic possibility of automatic definitions of ingress routes or gateway API routes. And you could have, of course, in the one cluster, multiple sites. By defining this micro frontend class, you could basically run multiple sites into one cluster. So it's not restricted to one micro frontend class or micro frontend site in the cluster. The next thing, when you build a system, you basically, what you need to know from the architectural or the conceptual point of view is just the concept of the context and concept of the routes. So each time you would like to define the micro features, you basically need just to define the context. Initially, you will start with a blank screen. In this blank screen, there is the initial context, which is the shell. And in this shell, you basically define your micro frontend, so even the shell is the micro frontend. Like you could have multiple application shells for each part, for each route, and depending on the route, on the display rules, you can decide which kind of the application shell you will show on the page. In this case, we displayed the material design shell, which is part of the project. Then, this material design shell has own context, so it defines multiple contexts into which, again, it's by loosely coupling, anybody can define the web component or additional feature and say, okay, it should show in this specific context. In your micro applications or the micro features, if you want to use some common component, just again, loosely coupled component who is taken care by the extra team, you again just define the context, and this way you can nest the features and communicate with between the components by using the event APIs. So because you have all these possible contexts, you sometimes need to depend on the external web components. For example, you would like to use some bundle, you would like to use some brand elements. You basically can just define the dependencies to additional micro frontends. Each time your micro frontend should be shown, it's loaded automatically, but it's loaded only on the demand, so only at the sites where your web components really should be shown. And to avoid some cyclic dependencies, there is also built-in cycle dependency checks, in which case you will get the error. Regarding cross-cutting concerns, there is some built-in functionality which solves the common problems of delivering the site. So for example, from the security point of view, there was already mentioned the content security policy headers, which you can configure for your, for your microsites. There's also some security kind of handling the roles, so you can specify display rules for the micro frontends to show the micro features just for the specific roles. Yeah, so you can read the roles from the headers, and you can decide, okay, for this role of the users, the given micro features is not intended, so it will be not shown. So it's not the access control, it's more the feature flagging, but helps when deciding how the front end should look like for the specific roles or specific users. We have also built-in support for the progressive web applications. You can configure the caching strategy, so you can configure it centrally for the whole micro front-end site, or you can have the specific rules for each micro front-end. In this case, you can get also some offline work with your micro front-end sites. And what we plan, we don't have implemented yet, but we plan for the server-side rendering, so we would like to have centralized server-side rendering, which will also then offload the teams from creating own server-side rendering solutions. So Michal now shows short demo.
Yeah, so it's called short demo, but it's really static demo, I would say. It's I decided to make it so that if you want, you can just look at the presentation, follow the steps, and you should get the same results as I did. Also, the results that I show here are not fully functional, but I will explain it. So first of all, what you need to do is deploy the controller itself, right? So if you go to GitHub, the Polyphia, and the Polyphia controller repository, you just clone it and apply our default configuration. Then you check if your custom resource definitions are installed, if the pods are running. It should work out of the box even if you have like completely empty Kubernetes cluster. So this is also what I take into consideration here in this demo. So you should see something similar to what is displayed on these two pictures, right? So the resources and the pod is running. Then, of course, the controller is not enough. You need also some UI, right? Because the controller itself is not doing it much. So we have this sample application shell in the repository as well, called the Polyphia MD shell. So it's built on Material Designs web components. So again, you just clone it, apply the manifest. We have manifest without sample apps, but if you want to see something very quickly, you can also use the sample apps as something to play around with if you want. So you just apply it, and again, if you have plain empty cluster, you can just port forward the service of the controller, and you should be able to see this exact application. So this works. You can click around it, you can see different web components there, but yeah, maybe that's not what you want. Maybe you want to add something yours, right? So again, I'm just hinting some ideas where you can look for some examples. So these links that you see here, this is the outcomes of the university lectures, actually. So we have some workshops with the students, let's call it like that, where they create their own micro frontends and they have to integrate with it. So we have some demos for that. I will use it further, but if you want to have a look, it's just a simple web component implemented with Stencil.js. So how do I make it sure that Polyphia is my front end, right? So first of all, you need the default deployment and some service, very basic. So from this deployment, we will just serve the bundle for the Polyphia to load it. That's it? No, of course not. You have to create some reference to the service because we wouldn't know where to look for the service and for the module. So you specify your web component, and yeah, you can assign it to this Fea front-end class. The reason why I'm not defining it in the demo because the sample application shell is already defining this class, so I don't have to do it again. Then you specify the module path, where to look for the module. So in my case, it's in build folder called ambulance UFE. It's UFE because it's micro frontend, so micro is not really a standard ASCII character, so we had to use U. Then this proxy flag is actually default, so you don't have to specify it, but it's by default true. If you would like to load it from, for example, I don't know, some CDN or whatever, you should be able to just specify this proxy to false and it should work. Yeah, then I have the link to the service. And now I want to put the tile in the front end, right? So as you could see that Jupyter or Saturn, sorry. So you want to see your application there as well, right? So you can specify, you can again use the component built in our shell. That's the element polyfea MD app. And you can configure it to display in different contexts. So it can be used for that applications. In this case, we only use it for that one, but you can specify this Railer also or the driver content. Yeah, then what happens when I click on it? So again, as I showed previously, you just specify another web component. This time, it's the web component coming out of my bundle. So I first define the display rule. So if it's in, I want it in the main content when I'm on this subpath, this M70 ambulance wheel. Again, it has my initials because we have a lot of students and we were all under the same namespace, so we had to make it unique by including some initials or something, right? So I'm on that subpath and I want to display it into the main content. Yeah, and I'm choosing this element, what's demo ambulance whale app, which is a waiting list app for a patients. And the last thing, specify from which micro frontend to load it. So what the controller will do then, it will query the module and the element would be registered. Yeah, again, it's not all. You have to deploy it, of course. So you just put it to some sample file and just apply it on your front end, on your Kubernetes. And you should be able to see that the micro frontends were applied and that the web components are also there. The rest is then handled by the polyfea. And then you should be able to see something like this, although it's not very visible. So the first thing is here, the tile on the right will appear, which is the waiting list for the patients. Then if you open it, it will not work, because the version that I deployed is a version where it is also integrated with Web API. And the Web API I didn't deploy currently, so it just throws some internal server error or whatever, right? So, but if you just, for the example, you can see that the front end is there and also it's working at least somehow, so some interaction is there. But you can try it out and you should be able to even incorporate your modules if it can be, if your framework can compile a web component, it should be able to work with polyfea. Yeah, thank you. And now I'm opening time for questions.
Maybe also for interest, even his presentation is actually part of solution, so it's kind of the micro front end which we build into this framework. Yeah, so thank you.
There are some questions. Where?
It looks great. Are you planning any other features? Will you welcome other contributors? Yeah, if somebody wants to contribute, it's welcomed. And from the other features, I mentioned the server-side rendering. This is what we would like to add. Then we had idea of, so there is this material design shell, which just follows the material design rules. We would like to have also something like the portlet solutions where the user can place the own widgets on the specific areas. So this is the additional idea which we have. and possibly there will come additional features. Yeah. How does micro front-end workflow compare to flexible managed tool like Cloudflare Pages that doesn't require building custom Docker files? So at least at the time when we were creating, and even now I was looking at the possible solution of the micro front-ends, how you would integrate front-end of various teams. One of the problems was that you either need to compile it in the runtime or you need to have the specific solutions. But for us, the primary goal was, okay, you use the Kubernetes and GitOps on the back end, you need to be able to do it also on the front end. Like there are various solutions for the micro front ends, but the common problem for us was, okay, that's additional technology, additional load for the team, additional load for the students. We want to explain to them that you need to work cloud native, you need to follow some rules, and this was actually just piece where we were missing, like to actually use the cloud native Kubernetes for the whole feature. But there are definitely multiple solutions. The biggest difference is, as I said, how you deliver and how you compile the micro frontends to integrated solutions. How does it compare to single SPI with its flexibility? Can be integrated with it to get the best of the both. Actually, it's the single server page application. And I would say that also the micro frontend should be single server page applications conceptually. And this, being the single page application is great, but if you want to integrate multiple features, then you will be challenged by how to actually get the common look and feel and how to deliver it in the one integrated solutions. As one of the examples, we had, for example, the project where we were using the timeline, but there was multiple features. And each feature actually developed its own timeline, which was slightly different from the other teams. So instead of that, you would like to have integrated solution where you just take the common component as the micro features and just let the additional or extra team, okay, you are responsible for creating the front-end feature for the timeline. Yeah, so this would be one solution. If you are a small team and you have everything in your hands and on the small projects, then you can also do it in the single page application, in the single application, that's also possible. It's also one thing you should not maybe overuse this possibility. Not everything needs to be separated micro features, so some balance is always needed. Do you use in production and Siemens? Any use outside of education? Actually, yes. We use it on some project, or I use it on the project, where actually I don't use MD shell, like material design shell, but I have the specific Siemens Healthineers branding shell, which actually has the feel and look, which is prescribed for the Siemens products. What do students say on the Kubernetes? Is there a space at Slovak and Czech universities to get to Kubernetes? Kudos for this, thanks for kudos. Yeah, they are actually excited. So for a lot of the people, Kubernetes, or for a lot of the students, Kubernetes is quite new. Yeah, so we have it's optional, like these are optional lectures, and we have 50 slots so for the 50 students, which can be accepted at the lectures. And in the last 5 years, we have always full, full 50 students actually. So they are interested. They are interested in the cloud native, in the Kubernetes and Docker. For some of them already works, but usually just few guys on the Kubernetes and Docker. And from the feedbacks which we are getting, they are really appreciating that Kubernetes is something they will need in the practice, and they like to learn it. Thank you.
Thank you.
To the Czech Technical University Faculty of Informational Technology, I would like to present our contribution to the Kubernetes Community Days conference, which is how we are teaching DevOps at this school. So we'll go over basics. What is DevOps? Or let's define what is DevOps in our view. Where it applies in the software development lifecycle, what professions are related to it, and what kind of professions would we like to bring up here at our university. And then we'll go over how we designed the course and what are the alternatives at different schools. So our definition of DevOps looks like this. It is a merge of 3 disciplines, let's say, which are firstly the development and the development best practices such as code versioning, work tracking, and so on. Then there is the circle QA, that means software testing and general quality assurance. And the last is IT operations. All these circles are intertwined, meaning that the developers need to learn the pipelines from the testers and should also take some care of how their application fares in production. Testers, of course, need to use pipelines, need to know how the thing is deployed, and the operators take practices from the developers, such as script, infrastructure as code, with versioning reviews, and so on. If we unravel these circles into a line, we have this kind of diagram, and there are different buzzwords underneath the timeline of the software development lifecycle. What it should show is that DevOps should cover the whole software development lifecycle. Automation techniques. The tenets of DevOps are that we are trying to automate basically everything. We want the processes to be repeatable scripts, to be treated as code, and that should bring us some benefits. Otherwise, we wouldn't be doing it. And what version of code is actually running. So when there is a bug that shows up in production, the developers would say, yeah, we already had it. This was fixed 2 months ago. So, or worse, they don't know what bug it is because they already forgotten. So DevOps is about shortening the time between an idea and its realization. What professions are related to DevOps? Because DevOps is a philosophy that talks about collaboration. There was a misconception when this buzzword first came to be. The managers thought that DevOps means, yeah, the developers will do the operations, we don't need the administrators anymore. Unfortunately, that was not true and is even less true nowadays when the DevOps field has grown into a very wide breadth of technologies. So we also need multiple professions to take care of different parts of the software development lifecycle. So in the planning phase, we would have from agile development, a Scrum Master and product owner. Then in code phase, there is the developer, of course. And then comes the usual DevOps guy. I would specify it more clearly as the build and release engineer. So if you're hiring a DevOps guy, you most likely need the build and release engineer who is active in the build, test, release phase. He's building the pipelines, making sure it passes, helping the testers and developers write their scripts. Then there is the tester, and right next to the tester sits the DevSecOps engineer. That's the guy who implements the shift left strategy and shifts security from the operation phase left in the timeline into the testing, so that bugs are encountered before the application is even running. SRE, System Reliability Engineer, or maybe I learned today that maybe it is the platform engineer, maybe this buzzword got renamed. that guy is most active in the deploy and operate phase, and also takes care of the cloud platform itself. So there would be another line joining here before the deploy phase, where the SRE guy needs to provision the cloud resources so that this software deployment pipeline can even run. And the FinOps is someone who monitors the cloud spends in the operations and gives feedback back to the planning so that the application is built with costs in mind. So this is a wide range of professions, and our school basically got the feedback that our people who are leaving the school are not fit for practice because they don't even know what code versioning is, much less all this spectrum of new technologies. So that's why we designed a new study program a few years back, I think 2021, a new version of the informatics study program with this in mind. So this is how the program is structured. We've got some prerequisites that are common for all specializations in this program, such as Unix-like operating systems, because you cannot do any DevOps before you know the Linux command line. Sorry, but that's the reality. Then we have the cryptic subject development, software development technologies with less cryptic abbreviation BI-Git. So that's where we implemented the ask that our leavers of the school need to know code versioning and branching and so on. And after that, in the third semester comes our subject, Introduction to DevOps, where we continue with that, teach them how to track work, how to build a pipeline with building and testing. Also, some DevSecOps comes into play. And in the second part, we teach them how to package the application into containers and deploy it either on virtual machines or the more cloud-native way on Kubernetes. Also, there is some infrastructure as code and monitoring at the end. We struggled a bit with what kind of program to teach this on, because we've got 3 specializations who have this subject as compulsory, and they do not have the same programming language in the prerequisites. So programming and algorithmics, that's C and C++. Then the most numerous are software engineers who have Java, and web engineers have either PHP or Python. So we standardized on Java, which the majority has, so that's our sample application. After introduction to DevOps come other subjects in our specializations, which can continue with this line, and I know that software engineers in their projects are heavily using what they learned in our intro to DevOps. And yesterday I spoke with the teacher of administration of database and web servers, and he also promised to bring in some Ansible into his teaching at least. So, as you have seen, we have multiple specializations, and there were different requirements. From the software engineering, they wanted mostly the first part of the pipeline, building, testing, static code analysis. Also teach what different environments mean, and they wanted some GitOps inside. The more administration-heavy specialization needed the second part of the pipeline, such as using clouds, infrastructure as a service and platform as a service, how to prepare the cloud environment, that's the work of the SRE engineer, and do a continuous deployment pipeline so that an artifact gets immediately deployed. Unfortunately, nobody had enough knowledge to teach this whole spectrum. So we joined forces of two departments, Department of Software Engineering and Department of Computer Systems, plus some experts from practice. And we created a compulsory bachelor's subject. It is practical, more practical because 60% of points are from practical exercises and 40 from the exam. Before us, there were subjects mostly in the master's phase of the study, where there were quite little numbers of students, where a lot of gave up because of difficulty of the subject. However, the difficulty was because there were higher expectations. In the master's phase, you can expect somebody to become DevOps architect, to design pipelines, take case study and design something accordingly. While in the bachelor's phase, you need to lower the expectations. We strive to teach the students to use the technology and apply the principles to a slightly different task, but still basically the same task. However, because we introduced the DevOps earlier than was in this previous literature, we can follow up in other subjects and repeat. And this way, most of the students from our specializations, software and web engineering and computer systems, will have this knowledge. What technologies we used? We are heavily focused on GitLab, which is our platform for code versioning, work planning, code reviews, CI. That's all. Our sample application is in Java, as I said. We are testing using JUnit and Mockito, plus some demo of testing user interface in Selenium. And we have SonarQube for security analysis. The second part of the subject uses OpenStack and Ansible. We teach how to work with SSH keys because that's the first subject where they meet them, besides access to Git. We have container tools, Podman and Builda. GitLab also serves as a container registry. And in the role of platform as a service, we have OpenShift, which is a distribution of Kubernetes. Terraform is an infrastructure as code tool, and Prometheus is for monitoring. And at the end, a few pictures so that it is a bit more colorful. This is the pipeline at the end of the subject. Basically looks like the theory. This is the result of our students from this semester, actually. It was more enrolled students than last year, 349 out of the 291 finished. English version and the remote version of the study had a little less success rate. However, in the remote version, you can see a lot of A's, meaning people who already had this experience, probably. And this slide is what grades did the student give us. That is the student survey. So looks like average 1.8. Yeah, still quite good. So, and as I mentioned, we had some expert in practice helping us with the subject, both with teaching and providing our sample application. And those came from a sponsor company. And my colleague Jakub Novák will tell you something.
No. Okay. Thank you. Well, I'm not a software engineer. I'm not a programmer. Well, I was before, but not yet. And I see that every one of you here is using some very professional ways how to improve their either coding abilities or software engineers. I had to find out what does the K8S means, for example, before this presentation. I'm very proud of it that I already know it. I know that you know it, of course. But not only me, it's the whole faculty that we have here. That's actually the same place we are here right now. I wanted to tell you more about some numbers. I found two of them. Well, I know from the head that we have around 2,000 students here, and all of those are those experts that that Thomas was telling us that we that know everything about the whole programming cycle, whole development cycle. But he mentioned sort of that those students are not well. They're more in theory than in praxis, but not only. We have like 20 laboratories at our faculty and 13 research groups that well have this impact on them to find out something out of praxis. We don't want them just to know the theory. We need them to be able to, after finishing and completing their studies, find out some good job. Maybe with you, maybe from one of your companies, or maybe if they will be very good, then we want to keep them with us. But where to? Like those 20 labs or 13 research groups, those keywords that you can see over there just mixes something that is actually right now well known. Those buzzwords are embedded security, data science, ethical hacking, image processing, programming research. If you add a word laboratory at the end of each of those words, you'll get the laboratory that we have at our faculty. So that's really the place where those students can get something out of practice. You know, like real praxis. We have projects with commercial companies. We do artificial intelligence. We do UX testing. And everything that's that has something in common with these buzzwords. Those guys, I mean students, that they are really good. We'd like to keep them in our labs, make them something more, and then let them to your world to be for you to be much better than they could have been without the practice in our lab. Maybe for you is one of those labs is much better for you than the others, and I wanted to mention the programming language, programming research laboratory. Those guys are our international team with the Professor Kirsch from Austria, and they were really successful at getting some huge projects like Big Code or evolving language ecosystems. All of those are public grants that you can look into, and all of those produced a really huge number of students that are now not only theoretically able to think about development, but doing them in practice in this laboratory. Well, if you're there a company and you know that we finally have some students that that are able to work somewhere, so you can maybe look for students, or you can look for professors at our faculty. Those are our only commodities that we can offer to you, if you're a company, of course. We have these really great students. Two of those are over there. And if you want to get in touch with those students, not only to come to this conference, but join us with the sponsoring program, or if you want something more than those well-studied guys, you need more studied guys that are our professors. Like, for example, this Professor Pavel Surinek, who is a great guy at robotics, with his robotic agents laboratory over here. If you want to get more out of those, and I mean professors, you can ask us to become our partner, and maybe to have all of those previous big-scaled projects that we get from publicly funded grants together with us. Or our biggest commodity here is something that looks like almost the same thing that's happening right now outside these doors. And it's our job fair that's almost similar at the very same place that we are here right now, but it's crowded with students. I was there. I was there in the lobby. There are many of you guys, but it's not crowded. Imagine yourself like 10 times. Imagine yourself a little bit younger, and then you have our job fair that's happening over there. We have like over 60 companies that are really wanted to present themselves to those students. The students' crowds are just flowing through those space, and they're getting well. Students want to see the real companies that can offer them something in practice other than our laboratories. So if you're interested in there, maybe we can meet again at our job fair that will be happening at the end of October. And maybe with some of you we'll be having our contract signed. We'll see. If you want to meet us, we can meet in person or we can meet online with the whole Department of Cooperation with Industry. Thank you. Perfect. Please tell me there is a company here somewhere. Are you a company? 1, 2, 3. Okay, we need more companies. And the others of you are students? Yeah, or employees. Oh, cool. We don't want to promote our study programs. We know that you're after your studies maybe. Or if you want to, you can attend our postgraduate program. We call it an industrial PhD. You can be funded from your companies or other companies. We can find you some that's interested in the research. And you can get your PhD even in your 30s or 40s, 50s. Okay. Okay. Fine. If you don't have questions, well, thank you for your attention. It was a really pleasure to tell you something more than welcome at our faculty, and maybe we will see each other somewhere with the contacts that we posted before. Thank you.
Yeah, let's give everybody 4 more minutes to get into their seats. We can start. No, we're waiting for everybody to arrive.
So now 4 minutes?
And those who are sitting, please fasten your seat belts.
Okay.
Because heavy load is ahead.
You do clicky click or?
Yeah, okay, I'll do the clicking. Okay. So yeah, let's assume everybody arrived.
Oh, it's like four more minutes. So
Okay, we have 4 minutes. Let's do something entertaining. Like, do you know any dance moves?
no.
No.
What's anybody has the fastest typing on the keyboard? Like if it's about 50 words a minute. Yeah? 100 words per minute. You got it? 100, huh? Say again? 120. Anybody more? How much you've got? 140. Wow. Is it which layout? Like a QWERTY or a Dvorak or anything? Anybody's fancy layouts? No? Okay. Is it split keyboard or just regular? Mechanical? Of course. What loop do you use? It's weird. Okay. Yeah.
Okay. Okay. And of course, you can ask us anything by using Slido. And yeah, let's start.
Yeah.
Shall we?
Yeah.
Okay. Hi, everyone. I'm Ant Weiss. I whisper at clusters at perfect scale. And today we're going to be talking about load testing.
Yeah, and I'm Ivan. I work as site reliability engineer at Perfect Scale. So we build a platform, probably as most of you. And we will be talking about load testing in Kubernetes at scale with K6.
Yep. Okay, so an interesting question that I haven't asked yet. Who here considers themselves developers? Okay, a few hands. And who here is on the DevOps SRE side of the equation?
Nice.
Okay, most of you. Well, quite expectable. What do developers care about Kubernetes after all?
What?
So this is a question to the platform folks. Has it ever happened to you that the developers come and surprise you with a question you don't have a good answer for? Yeah, happens sometime, right? And something like that happened to you even, right?
Yeah, so a couple of weeks ago, so at Perfect Scale, we have admission controller in Kubernetes. We receive a lot of requests and we serve them. And now the question was, hey, we expect to have higher load to our admission controller. How will it behave? And I don't know.
Yeah, so even, actually, how do you answer that question?
Well, is it like how it behave?
Yeah.
How it behave? Is it like
what's the behavior, right?
Yeah. What is the behavior? So one question of that is actually asked is, I have my expected load. Will my application support that? So you can have a change in this expected load. Or what is the load, maximum load my current configuration can support? Or we have an SLA or we have an SLA change. Will I be able to maintain this SLA as my load goes? And usually underneath all these questions, you have another one. Where is my performance bottleneck for my application? What, like, when I hit the wall, what is the wall I'm hitting?
Right. So to answer all of this question, there is a technique that's been a little bit forgotten in our cloud native world, and that technique is called load testing or performance testing. So who here does load testing for their workloads?
Oh, wow.
Okay, we have a number of hands. more or less maybe like 15%, I would say. So yeah, it's like, it's old. We've been doing performance testing 20 years ago, but somehow in our cloud native world, this has been forgotten, or maybe we're just scared to do load testing because it gets very complicated, right? Because in the cloud native world, it's very hard to define what our SUT is. So an SUT is the system under test. And when we're cloud native, suddenly this system becomes something very ephemeral, right? We have lots of services. Each service is running multiple replicas. And these replicas talk among themselves in multiple protocols. And we don't really know what kind of test to run because there are open model load tests and closed model load tests. And it really depends on what's that question we're asking. So it's not easy.
Yeah, and what makes it even harder is that as we found out that it's not a one question how it will behave, but it actually so much more questions, and you can go deeper and deeper the stack. So after all, what is, like after we answer the question how my system will behave, we have a following question, where is my bottleneck? And so there was a presentation here today before us, and they said, well, a cloud, they say it's finite. It's infinite, but it's not infinite. So all our resources are not infinite. And we always need to remember that we always have some bottlenecks in our application for memory, for CPU, our network, connection pooling to database or whatsoever, or if you have distributed system that the components talk to each other. So you always have bottlenecks somewhere down the line. They do not scale infinite.
Yeah, and the reason why we care specifically about performance and resource consumption is, of course, again, because we work at Perfect Scale. What Perfect Scale does is optimizing the performance of containers running on Kubernetes. And what we know is that setting the resources, the requests, and the limits for containers is very important because bad things happen when we don't set them correctly. You can see this table here that has a very good representation. When we're under-provisioned, of course, there are always reliability and resilience issues. But even when we're over-provisioned, we're not only wasting money, but also we lack the cutoff switch that can lead to the noisy neighbor problem. And of course, if we're not defining anything because we haven't load tested and we don't know what the requirements of our applications are, then of course nothing is guaranteed. So yeah, I hope we've convinced you you need to do load testing, and that's what the conclusion that we arrived at, and we decided to do it, but then we had other questions, right?
Yeah, so we have a platform, and what tool are we going to use in our platform? There are many for load testing. For it at Perfect Scale, we choose to use K6. It's very simple.
Anybody here tried K6?
K6. Yeah.
Okay. A few hands. Okay. Yeah, it's relatively new. That's also another reason why we decided to try it, because we like new shiny things.
Yeah. Well, and it's simple, goal-oriented. So you get a result out of the box. It's easy to understand what's going on in the test cases, and it's resource optimized. It's written in Go. We are Go workshop, so we know how to read the code and fix it if you want to. And it's automation ready. We can integrate it nicely. Of course, who doesn't like writing test code in JavaScript? And it does support, as you run it inside your Kubernetes, you have a plethora of the tools you have for chaos engineering as a part of a load testing. Or, for example, you can use your favorite monitoring tools to see what's going on during the load test. And there are many open source examples. It's a part of CNCF. And if you want to climb a mountain, why not climb K6?
It's an actual name of a mountain, by the way.
Yep.
A mountain. I think it's in Africa.
Africa Mountain. Yeah. Anyway, that was a joke.
So K6 is an actual name. You can Google it. Okay. And another reason, again, we're running on Kubernetes, and there is a community-supported K6 operator that allows you to run K6 on Kubernetes, the Kubernetes way, following the Kubernetes resource model. And basically, that's where we are. We run everything we do on Kubernetes, and our customers run on Kubernetes. So yeah, that was the natural choice for us. And that's distributed load testing for you. So how do we do this, Ivan?
Yeah, so two important things. So we are going to do this more info, and then we will have a demo. So this is like a first very simple test example. So this is a code that will be executed as a part of load testing. And here you can see a default function. This is something that is executed in parallel, in a parallel of number VUCs, which means virtual users. So this loop will be executed in parallel 10 times for a duration of 10 seconds. In this case, we are doing a closed loop model load testing, where we will wait for results or until this function executed, sleep for 1 second, and only after that, this virtual user pick up the other function. So this is like a first important part. And of course, in the task, you can specify way more details. For example, ramping up how much requests you send, or you can use different virtual users. You can have a different scenario. So like not only default function, but a couple more. And it supports a lot of protocols. So gRPC or some native databases protocols for some of database also connected. So let's go to the second part. So
and what about this create config map command?
Oh yeah, right. So we are going to run this inside our Kubernetes cluster. So there are two ways how you can actually like kind of deploy this code to the cluster. The first way is create a config map. That's our preferable way. And you can mount it as a volume to executors. So this is like if you will want to replicate it in your cluster, then create config map, and then.
Yeah, so once we've written the test, we've created the config map, we've put it in the cluster, then?
Then a test run. So this is a CRD, K6 operator operates, and it's a kind test run. In some of older versions is K6. You specify namespace, and you have parallelism. And this is a cool thing. Why? Because sometimes you want to run a couple of replicas in your cluster, and you want to, for example, locate them in different AZs. Let's say you have your service running distributed in a couple AZs. You want to load it as you would have a users coming, like a user request coming. So you can do this with parallelism. You can specify all the pod specs, like pod affinity, taint toleration, anything you like. You don't want to get limited by network bandwidth to hammer some of your favorite services. So you specify parallelism. In this very simple example, we provide a script, and the script is, in this case, is a config map we created previously. So what it means that we will execute, so we will divide our 10 VUs across this 4 parallelism, so every job will be executed two and a half, whatever it means, and it will be executed default function in this parallelism in our cluster.
Okay, so I know you're full of theory now and you'd like to see this working in practice. So the one final thing, we need to define what we're testing. So in the beginning, Ivan told us a story about how the developers wanted to know how our admission controller is going to behave, right? But that's a new story that only happened last month. But we already have another component that we are load testing, and that's the pricing component. So this is our architecture in a nutshell. So we are collecting performance and reliability data from the customer's clusters, and it goes to our backend, and the backend is distributed. It has multiple components. And one of the very important components in our system is the pricing component, because we're optimizing clusters for performance, but in the end, we're saving you cloud costs. So we need to continuously pull the costs from the cloud, augment them with your special discount data, et cetera, et cetera, et cetera. That's what the component does. It has to be highly available. Different other components talk to it. So we need to make sure each time our developers release a new version that there was no performance degradation, right? And that's exactly what Ivan is going to show us.
Yeah, so let's move to a presentation side.
But first, a small prayer to the demo gods.
Oh, wow. Okay. Okay, so I don't know how to talk and do this. I do. Okay. 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 So, as a platform, as a part of our platform, we heavily use GitHub Actions. Anybody use GitHub Actions? Yeah, that's really nice. So we are going to provide two inputs, this image tag 1 and image tag 2. So we are always want to compare versions when we do a load test, and we want to isolate them. So we are deploying two versions of application, and then for each version separately, we are going to run a load test, connect to the cluster, all that, install a separate, we use Helm chart for deploying. We run a load test, we wait until it's finished, and we clean everything up. So I'm going to run the load test, and
so if I understand correctly, in order to run a test, you need to create a custom resource, and then in the end, you need to delete it, right?
There is a detail. So if you're going to apply again the same CRD, it won't be rerun by K6 operator. So we are always cleaning up. So we expect our image tags match commit references. So I'm going to provide two versions. I'm clicking run workflow. And this is running. So we have 3 jobs: run for image 1, run for image 2, and then we have a summarize. So as it's running, let's go and check how it looks, this benchmark. So this is a slightly more complicated example than was in what I showed you before. So we are going to execute this function in our views. And we are sending the request to this URL, and this variable we pass as a part of GitHub action. So this load test will hammer on this specific service in the cluster, and this is our static payload. We don't care for this about all database caching and stuff. So we're just receiving. And then we are comparing a status code, and if the check is a very cool function inside K6 that allows us to check response codes or maybe content of responses. And this is this slightly more complicated test case, and then how we are going to execute it.
So this is JavaScript, but it's not that bad, right?
Yeah, it's not that bad unless you have more than one file, and I'm sorry, I actually wrote in JavaScript. That's a very nice language. And we are executing parallelism. So this will run in 2 jobs. They're not going to run a separate host. I don't care for this case. And I'm going to map this config map, main.js. And this will do the magic. And now a couple more details that we are using experimental output feature of a K6. So K6 support a couple of ways how we can output results. And one of them is actually pushing the metrics to Prometheus remote write. So that's what we are doing here.
Anybody using Prometheus remote write, by the way?
Yeah, that's cool.
Okay, a lot of you.
Yeah, nice. And I'm providing tags.
That's not the way Prometheus was originally designed to work.
Yeah. So we are having a tag 1 and tag 2, and this will complement our metrics exported to Prometheus. So our metrics will have this cardinality of which test ID it's associated with, and in GitHub Action it's associated link to our GitHub run ID. So we are able to see, oh, in Prometheus this is what the metrics we get, and we pass the version ID, which is in our case corresponds to commit ref. And there are like a couple more details that allows us to build nicer dashboards in Grafana as a result, and we provide resources. So let me see if it's finished. Yes, it did. It did, and we have a summary. I click load test, and the way how it works, we just plug in this variable as a template. When we open this link, and we can see 2 test results. We can see how much peak load we reached in this test runs. We can see latency, so 99 latency was 141 second here, and for the second one, it was slightly lower. So I think we're going to check with developers and products if they're fine with that and see if we proceed or no. So that's it. I'm going to...
I say no.
What?
Let's make them rewrite the code.
Okay. Okay. Slideshow. Okay, so, and a summary. Oh, another thing, we did a cool thing. We actually benchmarked S3. We use S3 for storage. So if you want to see more like detailed and slightly more complicated example, go there. There is like also code available on GitHub. And yeah.
So K6 is good not only for testing the services on Kubernetes. Basically, the thing we were having is we're having some weird latencies.
Like we had S3 throttles, and it's like a kind of rookie mistake. But we already did partitioning for prefixes, and we assumed that it works, but it was not working as we expected. So go check it out. Maybe it will be of an interest for you.
Yeah, it's a good. It's the one you've written, right?
Yeah.
Okay. And yeah, so to summarize this all, hopefully we've convinced you that if you're a responsible SRE/DevOps/platform engineer, you should be load testing your services before putting them in production, because otherwise you can't be sure your service is going to be running reliably and will be able to support the load that it's supposed to support. But it's also important to think of the fact that no matter how much we load test before going to production, there are things we cannot really test, right? Because this is a distributed system. Some parts of our system are managed services that we don't have control of. And weird stuff can happen in production because the networking is different, et cetera, et cetera, et cetera. Some slowness in the system can be related to that, right? So it's very important to continue monitoring your performance while in production, even when you're not load testing, even when you're running with real traffic. And for that, you have perfect scale, of course, if you're running on Kubernetes. And that's what we do. And we have a free trial, 30 days, connect your clusters, check how performant they are and how much do they cost you and how much money you can save. And with that, we'll be happy to take your questions. Do you have to use config maps for scripts, or is there any other way?
Yeah, so you can put your code in volume, mount it to pod, and just go from there.
Yeah. In general, if you have longer scripts, and K6 allows you to build very complex scenarios. So the things we showed here are simple stuff, but you can go much more complex than that, with many more threads, all kinds of load. Like, for example, here we didn't take care of responses at all. It was 200 or nothing.
So you can have like conditional handling of responses. Let's say you receive specific response, you send another request to other service, and you can do that, define the flows.
So when the scripts get more complex and you can even have modules, again, this is JavaScript, so you can use anything, then it makes a lot of sense to put them on a volume, like have a whole repository of tests that you're running. Okay, what is the fine balance between too much load testing and no testing at all? Tests themselves provide some stress for prod environments. What is tolerable in percentage?
Well, okay, so this is a good one. I think for you, you decide coming from product requirements if you can actually go to production without load testing or no. Maybe some features you expect to not have much load, so you can actually roll them out with integration testing and unit testing. And for some features, you want to make sure that you're good in terms of SLA before proceeding. The answer to that question, I do not know. It depends. And tests themselves provide some stress. In the cases which I shared, the test we run in dev environment isolated the installation. In production environment, you could use something called synthetic users to provide soak testing. It's a one-off category of load test when you always create some load to your environment, and you always have the synthetic users that you can monitor in case you don't, for example, have enough load in production environment. But I would suggest you not to run heavy load, like spike load testing in production, or at least ask your teammates and managers if that's okay, so you don't interfere with your customers.
Yeah, and another way to do this is, of course, running in blue-green environment, where you have the live environment and the other one where you can run the load tests, verify that everything's working correctly, and then switch over the traffic.
Or you could copy part of the data to lower environment and do a load test there. That would be more safe approach, I think. But maybe YOLOing sometimes is good. I don't know.
Is there a way to parameterize the script?
So in the example, the last one I've shared, we provided. Oh, I think it's okay. It's not. It was in VS Code. Yeah. So here you can see that we read from environment variable called SVS endpoint, and I pass this environment variable through env here. So this is one of the ways. There are more complex options where you can provide a config and override it. For us, environment variables were good enough to use. Okay.
If you load test an app without any limits set up, will it max out and possibly break the cluster? That depends. Yeah. Max out on what? Again, for CPU, it's probably not going to overload because, in general, we don't recommend to set up the limits for CPU. You may have heard about this, but it comes down to the point that the Linux kernel scheduler is a totally fair scheduler. So it takes care of limiting the CPU usage anyway. So CPU limits can actually cause your application to throttle even when there is CPU available. Okay. So like the overall recommendation, don't set CPU limits for your containers at all. Okay. Regarding memory, if we don't set up limits, yeah, then potentially that specific application can overtake the whole node. But again, we're talking here about testing environments. So you do want something like that to happen when you're running the load test, because that helps you discover that there are issues. And then when you discover the issues, you fix them. And when you go to production, you're certain, or at least sufficiently certain, that it's not going to happen.
I'll add here that I recommend always running this load test pods on separate hosts for different reasons, not for reasons not breaking the cluster, but for reasons that you will have a whole bandwidth for yourself on inside this instance. So it will allow you to have a more predictable load that you are able to execute on the specific executor. No, it won't break the cluster, But if you collocate the pod with some important production component, it can fuck you up a little bit. But usually you'll be fine, but you'll get non-consistent result for load test.
Yep.
Any experience?
Do you expect from what?
I was like, I think the second.
Any experience with combination of load testing combined with function test and recording behavior on client accessing?
We do not do that at Perfect Scale. This is a very good one. I think we will end up there someday. I hope so. To record the traffic, replay, even compare results. But it's a bit time-consuming to build that. I know there is a product called Melocious, something like that, that allows you to generate client behavior, but it's like more of a just functional testing. So no, we don't do that. We more of like check what like percentage of requests land in the specific flows of your application, and then we are able to write a specific scenarios and execute them percentage-wise. That's approximate to our production load, if you go to this direction. So the next one, do you expect from Grafana monetization some pattern changes for K6 in future? Anton?
Yeah, we all know there's been some changes in licensing in some of the tooling we've been using, like Terraform is a good example. I suspect Grafana are not building on monetizing K6 specifically. What they do have is when you run K6, they provide you a very easy option to output the results to Grafana Cloud. And it's easier to set up than what we did, for example, with Prometheus Remote, right? So I think it's their way to lure you to their commercial solution, but K6 itself is going to stay open source. And again, it's been submitted to CNCF, so now it doesn't belong to Grafana anymore. So.
Yeah, and I think for K6, usually not a lot of engineers run load tests so much, so I feel safe with that, but you never know, maybe tomorrow they close it.
Yeah.
So Perfect Scale is one of our competitors, but not really, because it allows to set up an air-gapped solution, and from our experiments, their algorithm did not provide sufficient resiliency fixes for workloads. So I'm quite confident that we provide better resource recommendation, and we also work in multi-cluster environments. So it's slightly different use case, but if you're happy with that, good. It's something similar to VPA, and there are like other players in the field.
In fact, if I remember correctly, Goldilocks is basically on top of VPA.
Yep.
It allows you to manage multiple VPAs, because one of the bad things about VPA that you have to define a VPA resource for each of the workloads you want to manage.
Mm-hmm.
And then Goldilocks allows you to centralize all of this and provide you a nice dashboard, and et cetera, et cetera, et cetera. So yeah, it's saying VPA is not good enough, so we'll provide a solution on top of that.
It is good. I love the idea. If you have success with that, nice. If you have multi-cluster environment where you want to have like more central managed thing, and we do have a couple more indicators we take in account when doing resource recommendation. So welcome to join our trial and maybe share feedback with us.
And regarding VPA, if you ask about Goldilocks, Goldilocks works with VPA. VPA is a great open source tool, but it has its limitations. And if you want to better understand what its limitations are, we just recently, I think last week, we released an ebook in collaboration with Learn Kates. Mm-hmm. And it outlines everything, like all the upsides and downsides of VPA, and it's written by Daniel Polanczyk. Some of you may know him. And it's really a great ebook. Go to our website, perfectscale.io, download it. It's totally new, released, as I said, 2 weeks ago. A nice read. So yeah, fully recommended.
Thank you, guys. It was very good questions.
Thanks a lot. And thanks to the organizers of the KCD.
If you have any other questions, we'll be around, so feel free to just come and chat.
Hello, everybody. My name is Gabriel Iles, and I'm from Grow to Fit. And I would like to talk about about how to use OpenTelemetry collector in observability for distributed systems and edge computing. So, as I mentioned, I'm working as a senior DevOps engineer for the Grow to Fit. I'm in the DevOps more than 3 years. Before that, I was working as a solution designer for big data solutions. And I'm now more than 1 year, I'm working on observability in Kubernetes. So, what is observability? As most of you know that observability is not just about monitoring, so collecting metrics and visualizing that. So basically, it has other 2 pillars, so collecting the logs and traces from applications. And in most of systems, those 3 pillars are handled separately. So from my experience, always the first thing that people implement is a monitoring, and the other 2 things as collecting the logs maybe could be the second one, but it's very few of projects using the collecting tracing from applications about the behaving the applications. So I would like to talk about all the 3 aspects of the observability, so and how it is implemented in OpenTelemetry. So today there was one presentation about also where the OpenTelemetry was described what it is. So it's basically a vendor and tool agnostic framework which can generate and manage telemetry data. But as also was mentioned from my fellow speaker, that it is not a backend for observability, so it has no storage. What you need, an additional storage where you can send data from using the OpenTelemetry. It basically could be Prometheus or Thanos or other backend used for traces or logs. So the main component of the OpenTelemetry is the collector itself, and it offers also a vendor agnostic, and it's a single binary what you can download and use from their GitHub repository. And as you see, the architecture of the collector, so basically it has 4 basic components as receivers, exporters, processors, and extensions. And from those, the receivers and the exporters are mandatory to use for the pipeline. So basically those 4 components forming a pipeline, you can see the orange or the green lines which indicates a pipeline. So each pipeline has own receiver. Then you can use some processors for processing the telemetry data, enriching or cleaning up, or just use some filtering, and then some extensions which provides additional features for your telemetry data, and then the exporters, which basically is sending out the data into the backend based on the type of the telemetry data, it's metrics, logs, or traces. So as you can see, there are the links for the 2 GitHub repositories. The first one is the official OpenTelemetry collector GitHub repository. It contains basic receivers, exporters, and components for the collectors. But there is a second one, which is called OpenTelemetry Collector Contrib. And it's an open source project and a lot of contributors developing additional receivers, exporters, and other components. So it's provides more features and lot of more components for the usage. And also there is a third one, which is called a builder. So even you can build your own OpenTelemetry collector, and you can choose which components you would like to have in that image, and just use for your own usage. And the collector itself can be deployed in 2 modes. So, and that's basically what I would like to introduce you. So the first mode is the agent mode, when this OpenTelemetry collector is deployed basically directly or the nearest possible to your application running on the same host or in the same environment. And in that mode, it is deployed or as a standalone process, or you can deploy it in a containerized environment. And basically your application is sending data towards to the collector, or your collector scraping metrics from the applications, and then sending out the data directly to the backend or to other type of the collector, which is the gateway mode, which I will show later on. So basically the agent mode is, as I mentioned, is running directly with the application. So you can process the data locally and filter what data would you like to send out from the application toward the processing. And the second mode, as I mentioned, is a gateway mode, where the collector is deployed in a remote environment or in a centralized environment. For example, in a Kubernetes cluster, you deploy the collector in a gateway mode, and this gateway mode, the agent or collector, is getting data from the other collectors from remote locations, and then you can do so. In the gateway mode, the collectors can get data from multiple agents, and provides a centralized way to further processing the telemetry data. So you can aggregate them, use some of the processors providing by the community or other processors to basically process your data, and then sending out to the backend for storing the data. And the next thing what I would like to talk about is the operator itself. So the OpenTelemetry also provides operator for this collector, not just collector, but using in the Kubernetes. And this operator is managing 3 types of CRDs. The first one is the collector itself, which could be deployed in different modes. As you can see, as a sidecar in any pod, you just use some annotations in the pod, and the operator, when will see that annotation, it will inject the OpenTelemetry collector as a sidecar in that pod. So basically it also could be considered as an agent and collecting telemetry data. And the other 3 types of deployment are basically the Kubernetes most known types as deployment, daemon set, and stateful set. Also, the daemon set is very useful if you would like to deploy the collector on each node of your Kubernetes cluster and collect, for example, metrics from the node itself, as for example, Prometheus node exporter is doing. Then there is a second custom resource definition, so-called auto instrumentations, which basically also, if you define it, so the OpenTelemetry operator will inject all the instrumentation tools into the pod where you would like to use it to instrument your application, and it's providing different type as .NET, Java, Python, or Go, or something like that. And the third one is the latest one. It's a very interesting feature, the target allocator, because it could work with the Prometheus operator custom resources as a pod monitor, service monitor. So basically using those custom resources to get metrics from services or pod. So in that way, OpenTelemetry could replace your Prometheus instances. So you're just using the CRDs without installing Prometheus services, and the OpenTelemetry collector could take those beside the other features which you configure in the collector. And also this target allocator doing load balancing, so it will divide evenly the load between the collector instances if you have multiple, because the operator also allows you to auto-scale the collectors based on horizontal pod autoscaler. So you can define the auto-scaling for the collectors that it will auto-scale based on memory or CPU usage, and the operator will take care of the auto-scaling of the collectors in a Kubernetes. Oh, and basically this is a high-level design how you can deploy or use the OpenTelemetry collector to collect data from distributed systems. So as you can see that there is a installed collector in agent modes in some edge locations or even in a cloud environments. For example, you have your application running on a virtual machine, standalone, and you can deploy the collector beside that application and collect the data, and then forward the data to the collectors installed in a Kubernetes cluster managed by the operator acting as a gateway. And then the gateway collectors will send out the data to the centralized storage or tracing platform or where you can send and use it. So basically, in the end, it could be any other remote location and even different cloud provider. So basically, that's why the OpenTelemetry vendor and tool agnosticity came in handy, so that you use the same code and deploy it to any environment, and it will behave the same in all these environments. So divide or bring more detail this design. So let's see that how, for example, in the agent mode, the OpenTelemetry collector is configured. So basically, there is two pipelines. As you see that one pipeline, the higher one is for traces. That application is coded to send out traces, pushing traces into the OpenTelemetry collector, which using the receiver receive these traces, and then there are some processors configured. Basically, it's recommended to use the memory limiter and the batch processor, but you also can use a so-called attributes processor, which provides you that with feature add additional labels or into the metrics or additional information into the traces about your environment and so on. And also for the second pipeline for metrics, which is pooling as a Prometheus receiver, pulling out metrics from replication, and also it could work with the exporters which was developed or are available for any Prometheus. So basically, if you have some node exporter on the node, you can configure your hotel collector with Prometheus receiver just to use that endpoint and pulling out metrics from your application. And also in the pipeline, you can do some processing of the data. And as you can see that the two pipelines have one common, using the one common receiver, which is called the OTLP receiver, which is the OpenTelemetry protocol, and it provides HTTP and gRPC type of sending out the data, and it is very useful that using this OTLP exporter to send out the data from the agent towards to the gateway, because then you also see that in a gateway you using the same OTLP, but as not as exporter but as a receiver. So with communication between the hotel collectors using the same protocol and understanding each type of the data, so you do not need any further modification. And then in the hotel collector itself, then you can define again a different pipeline for your tracings and for the metrics, and then defining different exporters to send out traces to the tracing platform, and metrics sending out to some TSDB platform as Thanos or Mimir or anything else which can collect your metrics data. So basically this is about the design, how the OpenTelemetry collector could be useful collecting data, observability and telemetry data from distributed systems, which has multiple components on remote locations. And basically then you have just one centralized source for your telemetry data, and you can use those central source for visualization, for example, Grafana, doing dashboards on metrics, on top of metrics from all of your environments. And I would like to also talk about the performance of the OpenTelemetry collector, because in such a setup, when you have these multiple environments, you can have then heavy load on these collectors, and you can get a lot of data, metrics, and so on. So basically, the operator, as I mentioned, the operator can scale the collectors, but there are some recommendations that where to scale, how to scale, and what to scale. So basically, for example, there are very useful metrics, and the OpenTelemetry collector could monitor itself. So you can configure that when you deploy the collector, it's also providing the /metrics endpoint with useful metrics, which then you can use for checking the load or the behavior of your OpenTelemetry collector. For example, what I mentioned, this memory limiter processor, if you add this into the pipeline, you can set up that the collector, how much memory could use from your pod. So basically, and then if this limiter reaching this limit, for example, 80% of your memory could be used by the collector, then it starts to dropping the data. And that's, there are some useful metrics which you can use for monitoring the load on or behavior of your collector, and based on that, just scale the collector vertically or add more instances. And also there is a so-called capacity, queue capacity. So it's also configurable. The default value is 1000 data. And if your memory or the collector has a lot of data, so you can see that there is a defined capacity, and the size of your queue could indicate that there is something happening in a collector. So, these metrics are useful, but not in every case. The collector itself has problem when the data started to be queued in memory of the collector, because it's also on your backend. For example, if you have a Thanos backend and Thanos have this receiver component, and when the Thanos receiver is not able to write out the data in that amount or with that speed, so it will not give a backward acknowledge to the collector that, okay, I have written your data. So it also could cause that your queue in the collector start to fill up. So it's could be a good indicator that something is happening. But for example, if you start to increase the queue and you see that even the queue is increased, but the size is increasing also with that in the same proportion. So it could be the indicator that not your collector, but your backend is not capable to handle that much of data. And also there is another metric useful when you see that can indicate that the sending out was failing. So, and these metrics, you can see that at the end that it's mentioning that the spans is for tracing, but those metrics are available for all three types of the data. So the metrics will be called at the end not failed spans, but will be failed metrics and failed logs. So if you have all three pipelines defined in a collector, so those metrics will be available for you for the monitoring. And about the security of the OpenTelemetry collector, it provides basic authentication, so you can configure the OpenTelemetry collector using the TLS certificates, also basic HTTP authentication with username and password, and also it provides the OADC authentication which you can configure and connect, for example, to OpenID or Keycloak or something like that, which is used for authentication. And from the security perspective, it's also the good point to have the least privileges, and also what I showed before, that existing a builder, so you can build your own OpenTelemetry collector image just containing those components what is needed for your load or configuration, because it's also could increase the security of the collector. And the third aspect that don't forget update the collectors, because could contain old version, could contain some vulnerabilities, and it also could lead to security breach in your environment. So basically that's all. Thank you. Question, can the metrics sent from one agent to multiple different destinations at the same time? Yes. So you can define, as I mentioned, the pipeline, and you can define for the same data multiple exporters which will send out the data. As in, for example, in the Prometheus, you can define multiple remote writes destinations. Also, hotel collector have this Prometheus remote write exporter. So you can configure it in the same way as your Prometheus, sending out the data to the multiple destinations. When I start to using hotel, will I still need Prometheus? No. When my Prometheus is already just only scraping metrics and remote write it to Thanos, it's already just, so basically in that way you can replace your Prometheus instances with hotel. As I mentioned, it provides Prometheus receiver and Prometheus exporter. So basically you can take your Prometheus job configurations, put into the hotel collector, into the Prometheus receiver configuration, so it will scrape the same endpoints, same metrics what your Prometheus is doing, and then the Prometheus remote write exporter you can configure to endpoint to the Thanos. So basically it will replace your Prometheus instances, and you do not need to change nothing on your application and so on. So just take the same configuration from the Prometheus and put into the hotel collector. Can the application be blocked while trying to push traces to the agent? Trying to push traces to the agent. I don't know, because on a project when I currently working, we using some traces, but not at that level or that load. So I know that there are applications which are already sending out traces, and our observability platform is handling so far the data, so we cannot get any compliance from the applications team that our hotel endpoints are not handling or struggling with handling the traces. So far it seems good. Any recommended open source APM solution that supports or uses hotel collector? I'm not sure what is it, you mean the APM? Uh-huh. I don't know. Sorry. So that was the last one. Thank you.